Let's see.
Thank you again.
I didn't really assign 5 or 6, like that's because I'm going to assign it momentarily, but I want everybody to just only have to worry about chapters 1 through 4.
Yeah, I was just doing a bunch of everything. So I forgot to do chapter 4 post test, so I did it yesterday. And then I was like, okay, I will just do chapter 5 because I'm right here. And then I was like, no.
I was like, my brain's like, no, let's just do it until after the exam.
Do you feel clearer on chapters 1 through 4 or versus like 5?
Like, I didn't want to talk about 5. 5 was just out of my head.
Because I have a whole other worksheet we can do to walk through it more. So like I was telling we could go in or out of order, like we have 4 hours, so we could jump right back into Excel what we were doing, or we can do chapter 5. But I was likely, depending on attendance, like whoever shows up right around now, gonna start with their presentations, or we could wait till like 10, just so that like people are here.
I'm really comfortable with Excel. I can do it without even thinking about it now. It's just how long it takes when doing the questions, like enter all the data points, and do all the x minus 10 and square that, and then B8 minus whatever, like all this keyboard action. It just takes a long time. That's it. But I think I'm big good with it.
But the steps make sense. Okay.
Yeah.
I mean, I don't mind doing Excel, but I also like writing just so I can.
Yeah, and I would
Wow,
definitely
put it all in there.
know how to do it by hand, just because like Excel and the formulas totally work,
Mhm.
but I would probably still spot check that, because if you like do something wonky with the formula, you don't know the steps,
When you miss a number.
or you miss a number or something,
Yeah,
that
that happened to me a lot with the mean. Like I would do the sum instead of taking the average formula on Excel. But as soon as I changed the mean, everything else
makes
fits
sense.
good.
And hopefully, because of our infographics, when you all negotiate salaries now or in the future, you won't get the bottom of the barrel. Like that was like a life skill you can use, because if you're like, well, everybody's getting paid this.
I was not a drop in this.
Uh,
I
we-
had to do that, and I was like, kind of scary because I couldn't negotiate it. Seems like, well, we start at 14, and then he's like, once you learn how to give shots and stuff, it'll go up. And I was like, oh, okay. Where'd you find? I feel like do hospital pharmacy.
Did he tell you how much it would go up?
He said it would go $2.55 up hourly, and it doesn't matter if I like even give out shots or not. As long as I know how to do it. So that-
$16.25 an hour without a degree in hand is decent.
Yeah, and then
It-
once you get like the proper certification, it goes up to that. That one's the new one. Well,
Nice. Is it full-time or
it
part-time?
was part-time.
Yeah, that's what I agree.
It's good.
But
How's it going?
yeah, I liked him, like his whole like scene. I was like,
Morning.
yes.
Morning, Greg.
Continue this.
Oh, yes. All right. Our plans today is the presentations, assignments 3 and 4, more practice on chapter 5, and if we have time, chapter 6, with at least 2 breaks, maybe 3 or 4 breaks throughout the 4 hours, so that you guys don't fall over from exhaustion. Okay. Again, I'm absolutely aware the material is dense, everybody. Okay. So we should be. That's what I was going to do. I was going to grab this. This. This.
I said very, very, very.
Email. Nisha, you're here. Colleen, you're here. Alexa, no. Okay. Gustavo, you're not here. Valentin, Carlos, I see you. Nick, you're here. Jonathan, you're not. Annie, you're not. Katie, you're here. Ilona, you're here. Everybody's ready to present, right? I hope. Everybody that's here. Are you guys good? Are you ready to talk about your review? Yeah, and what chapters 1 through 4? Yeah, absolutely. Absolutely, yeah. Yeah, we're gonna start with the review, then which is your guys' presentations. We're gonna do that, then we're gonna do 3 and 4 and or some practice with 5. We can go in order, out of order, then move towards chapter 6. We totally have time. So did you submit in Blackboard? Okay, I'll grab it. Yeah, cool. It's grading, it should just come up. Let's see. Maybe over here. Welcome, everybody. It's right here, perfect. So I'm review presentation. Grade Center. It's Carlos. That. Zoom. Share. Share. Okay. Okay, cool. Thank you. And I have it up on both computers. If you think you can manage both, great. If you want help or you cannot, that's fine. But I have it on both the laptop for the recording and okay. No pressure though. It's just up there on top. It's fine.
Okay, this is my exam 1 review. Chapter 1, I mostly listened and reviewed. For this chapter, I found the majority of the material pretty easy to comprehend as it contained plenty of general information I've reviewed from the past. So my main tactic for chapter 1 was to sit back and listen during the lectures while trying to cement all the mathematical vocabulary being introduced in my brain. Though as we went deeper into the comprehension of the vocab with words such as continuous and discrete or grouped and ungrouped, I began to find it harder to differentiate between their definitions when identifying certain examples. So I created some study methods to better remember some main vocabulary words from this chapter. Continuous versus discrete. I remembered these words by identifying continuous as something that changes over time, while discrete describing something that is kind of set in stone. More specifically, discrete most likely comes in the form of a solid number, like the amount of markers in a box, while continuous is something that can change over time, like somebody's age. Quantitative versus qualitative. I established the differences in definitions, with quantitative strictly dealing with numbers, while qualitative deals with describing those numbers. I've learned that qualitative data can come in the form of storytelling, so I made sure to look out for more descriptive clues when identifying problems. I looked up several examples of both quantitative and qualitative data so that I can get more practice in identifying the differences between their meanings. Scales of measurement. Out of all the material presented in chapter 1, I believe I struggled most with identifying the different scales of measurement. I would be able to identify an example if I had the definitions of measurements in front of me, but struggled without them. So I would constantly refer back to a particular slide in the PowerPoint that would provide simple definitions describing each of the 4 types of measurement. And I know you said don't copy and paste out of the PowerPoint, but this slide in particular, I found the definitions like helpful because they were short and descriptive.
And that's, just so you know, for feedback, that's actually fine if you grab things here and there. I just want to see, because this has happened before in other stats courses, an identical replica of the PowerPoint. You made it your own, so you're fine. That's what I meant by that statement. So doing great, keep going.
So for chapter 2, group versus ungrouped. For chapter 2, understanding these vocabulary words in particular was a focal point. The way I differentiated these words was defining ungrouped as anything having to do with a solid number or range of numbers, such as 1 through 5, and grouped associates with random sequences of numbers that revolve around a story. When creating graphs like these on Excel, the best way I could study, understand, and redo this process was by mimicking exactly what was being presented in the Excel during the lecture. I then made different copies of that same example on my own time so that I can get a better grip of or understanding of the basics and mechanics of this software. I was able to use the Zoom recording titled Stats 6 2022 as an extremely helpful tool when looking back over the steps needed to assemble a graph or chart. Given that Excel requires very minuscule steps, the video format really assisted me by allowing for the chance to slow down parts of direction that I needed more time on viewing. Rewatching certain steps helped ingrain the entire aspect of Excel and graphs altogether. I also went over and studied our in-class assignment titled Homework 6-13-22 as a good tool for understanding the main vocabulary words from this chapter, such as cumulative and relative frequency. Chapter 3 for pre-test and post-test. For this chapter, I knew I needed to heavily focus on the tests, given that we are coming to an end of a unit, approaching an exam. For every question I came across that I hesitated when answering, I immediately used my ebook to look up certain sections revolving around my questions. Even though I've taken the test from prior chapters extremely serious, I put more time and effort into the chapter 3 pre and post tests for better preparation for chapter 4 leading to the exam. YouTube. To be honest, I never really took the time to explore the YouTube page provided for any chapter before chapter 3. But as we went through this chapter, I decided to look through every single one of the videos on the YouTube channel. There was no particular video that helped boost my knowledge, as all the videos collectively helped add to my overall understanding of the concepts we talked about for chapters 1 through 3. Mean, median, and mode. The mean, median, and mode were the biggest factors for this chapter, in my opinion. The way I studied these concepts was by looking up their Google definitions and referring to them whenever stuck on a problem. Sometimes I would mix up the vocab, so these definitions helped tremendously. And this was basically the Google definition that I found. Chapter 4, Zoom recordings. As stated previously, the Zoom recordings came in extremely handy for reviewing certain material in the previous chapters. Though for chapter 4, the Zoom recordings, in my opinion, were the most vital, especially the ones that broke down certain steps of mathematical equations used in graphs on Excel and SPSS. And again, the Stats 6 2022 Zoom recording was the most efficient in helping me understand this chapter. The e-flashcards for chapter 4. Similar to YouTube, I never took the time to use the e-flashcards that were provided to us throughout the chapters before this one. I played the flashcards game for a while until I had a basic understanding of most of the vocab listed in chapter 4. I then went back to the previous chapters and played the flashcard games for those two, as I found it pretty helpful in understanding the basic concepts of all the chapters. Chapter 4, post-test, listening and reviewing. As we were coming to a closing of this unit, I went back to my original study methods and decided to sit back and simply listen to the in-class lectures. I also took the post-test extremely serious, in particular for this chapter, as it is the test literally right before the exam. Reviewing the post-test along with the book and other study tools provided is what I did to understand this chapter and prepare for the exam. Overview. Overall, I used all the study tools in my dispense, including YouTube, Zoom, the book, and flashcards to best prepare for our first exam. So far, this has been a pretty dense and manageable course, as we have all the tools for our success at our hands.
John.
Sure, can I ask a question? Yeah. It's not. I say no, it's not. If you want to go next, that's fine. You did submit in Blackboard.
I
right?
did,
Right here?
yes.
Okay, perfect. Yeah,
We'll do some more.
absolutely. Yeah, that's fine. And we're totally recording. Just don't take 15 minutes or anything, but like a couple is fine. Let's download that for you. Think. Like that. You think, huh?
So this is my review.
Talk to me when he gets done, just so we give him the floor, but I'll talk to you.
For chapter 1, descriptive statistics break down the characteristics of a data set, also describing the data sample and its measurements. Inferential statistics helps test out hypotheses. In some cases, there are conclusions that can't be derived from descriptive statistics, and it can help making hypotheses and or evaluate data from a population. A parameter is a measure that describes the whole population in a sample, whereas a statistic is a measure that describes a sample. 3 research methods used in behavioral sciences can be correlation research, descriptive research, and experimental research. 4 scales of measurement and stats are nominal, ordinal, interval, and ratio. Nominal uses data being classified by characteristics such as a gender, for example. They don't have any specific meaning, but only use labels. Ordinal uses order or ranks, interval where variables have an order, but 0 doesn't exist. Ratio scale counting in order such like height or weight, or age, sorry. Quantitative variables are variables that result from counting or measuring, whereas qualitative variables are variables that aren't measurement variables, and discrete variables represent as a count of something, and continuous variables represent measurable amounts. Chapter 2, group data means data is formed in intervals such as 0 to 20 or 20 to 40, etc., whereas ungrouped data is individual points. Percentile points is statistics that shows the relative standing of a data point, whereas a percentile rank in a cumulative percent distribution is the percentage score in its frequency. Sample mean is the mean of a random sample values or numbers from the population, whereas population mean is the actual mean of the whole population. And then it said, do like the mean and stuff. So my example was that, and then the mean was that, and that's how I got the mode, median, and adding all the numbers in the data and then dividing it by the number of values in the set. The sample variance and the population variance are computed differently because the calculation in the denominator is different. The empirical rule tells you where most of the values lie in a normal distribution, and then standard deviation is never negative, sensitive to outliers, used to measure the spread and or the dispersion around the mean of the data.
Next, right, okay. And you just spin in Blackboard, right? So I
Yeah,
can
no,
find,
that's-
perfect. By the way, everybody, before she submits, and Carlos especially, so you see this right here? This is right now. This is everything from like, does it come up? Should, yeah. Oh. Recordings 2. Oh, no. I thought, okay, then I'm mistaken. I guess it's just, I thought I brought some stuff in. I'll double check that. I thought I brought in like previous semesters, but clearly that did not come through, so that's fine. There you go. And all yours.
Okay, Okay, well, this background can move, but I don't know how. It's fine. So chapter 1 was the introduction to statistics. It covered descriptive, inferential, population versus sample, different methods like experimental, quasi-experimental, correlational, scale of measurement, continuous versus discrete, and quantitative versus qualitative. So the difference for me for understanding descriptive and inferential statistics is that descriptive is like organizing and summarizing, and inferential just means like inferring. So it would derive like a meaning to be inferred onto a different sample or different population. The difference for population and sample is that population is an entire set of individuals. So like this whole, not this whole class, because that would be a sample, but like every junior at COD would be, or no, everybody at COD who's a student would be a population. Methods of research was experimental, quasi-experimental, and correlational. So experimental has to have high control, manipulation of independent variable, and randomization, and all of those must be present. Otherwise, it could probably be quasi-experimental, which is no manipulation, which is like your political affiliation or your culture, and it doesn't have control. Correlational does not equal causation, so just because it's correlated doesn't mean it's caused by that, and it also lacks random and control. And then something also mentioned was single blind and double blind studies, where single blind is that the participants don't know, but the researchers do, and double blind is either nobody knows, so that there's no bias or whatnot. Reliability versus validity in chapter 1. Reliability measures the consistency, so it measures like how often you can get this correct to make sure it's reliable, and then validity measures if it was done correctly. So that's the difference, is like consistency and correct. And then you can't have reliability without validity, because if it's not consistent, then you didn't measure it correctly. And then this one I have a difficult time understanding as well. Like I can understand the difference, but like finding examples, like one of the worksheets that we did, let's see if it was nominal or ordinal. Nominal is like something that's not numbers, so it can be like your age, your zip code, or just any variables describing it. Ordinal is anything ranking, is how I like to memorize it. Interval has no true zero, but it's also distributed equally. And then ratio has a true zero, and it is also distributed equally. So that's the difference between interval and ratio. Continuous versus discrete. Continuous, I like to think, is a decimal. So it's like you get like the 0.63 or whatnot. And then discrete would be like 0 to 1 and no in between, or like half of a person. Qualitative versus quantitative. Quantitative is anything numbers, because I like to think quantity for quantitative and qualitative for quality. So non-numeric and behaviors. Chapter 2 was summarizing the data. So we talked about types of graphs and charts, frequency distributions, and other types of distributions. So the types of graphs and charts we went over are bar charts, histogram, pie charts, etc. The difference between bar chart and histogram is that bar charts are drawn adjacent to each other and histogram is not. Pie charts are usually in percentages, either like a characteristic or whatnot. Frequency polygons are similar to histograms, but it's just like the line you see, like the stock market, I think, would be like a good example of that. And then we also covered stem and leaves plots and obgives. The last two I'm not as familiar with, because I don't think I went over that as much, but I think we have to know the histogram difference between bar charts. And then we also covered distribution types, which I have to like figure out, like the nominals, I have to figure out what is what by reading the example, but I think I can understand definitions. The cumulative relative frequency, I think cumulative is kind of like something like I don't know if anybody wants to tell me, because it's like 0.0 whatever, right?
Cumulative adds up to 1 or 100, depending on what you're doing. percentages,
Mhm.
but it's an accumulation of each of the amount all to 1, 0, or 1 or 100.
That one chart would help, where you get like frequency and then you get the cumulative frequency from the frequency. Did I? That
Yes,
one chart?
and we haven't finished assignments 3 and 4 yet, so we're gonna go through those things on assignments 3 and 4, and that should help too.
Mhm. And then honorable mentions include the group data versus ungrouped data, and grouped would be scores in an interval, and then ungrouped would be the intervals are not constructed. Percentile point is one value of score below that one value, but percentile rank is all of that scores that follow below that one value. To find the interval width, you have to do the real range, not the range, over the number of intervals. So the real range is 0.5 on each side, so it ends up being 1. And then we have upper and lower boundaries. It has the smallest value in each interval. To find the range, you do the upper minus the lower value. For chapter 3, we covered central tendencies, which are means, medians, and modes, and how to add, subtract, divide, multiply the mean. And then we also covered skewed and multimodal distributions. So for central tendencies, we have different types of means. We have the regular mean, which is the arithmetic mean, population versus sample mean. So it's just the n over n minus 1. And then weighted means are combined means. So you have to take, there's a formula in the book we have to use. Median is putting the orders in numeric order and not just finding what's in the middle, because I've done that quite a few times. And mode is what's most frequent, spelled wrong, but it's fine. So anything you do to add, subtract, or divide the mean, it will, what you do to that constant, like if you're adding or multiplying, will affect that mean by that constant. So like that one worksheet we did was, our mean was 8, and if we multiplied it by 4, we divided by 2, we got like 32 and 4 as the new mean. And for the distributions, we had normal, skewed, modal, and unimodal, and bimodal. The last 3 are just how many modes there are. So if it's unimodal, that's 1 modal. And then for normal distributions, the mean, median, and mode are all at the same point at the center, like they're all on top of each other. And then skewed, if it's the mean is greater than the mode, then it's to the right. And then if it's mean is less than the mode, it's to negative skewed. So for chapter 4, we had variability. So we covered sample versus population, quartiles, interquartiles, and semiquartiles. I have a difficult time trying to find the interquartiles and semi-interquartiles, because I know that was on the chapter 4 post test. The computational formula is great. It's the E, we'll see it later in the next slide, but standard deviation and how to add, subtract, multiply, divide from the standard deviation. And then we did like 4 hours of Excel work in this class. So then we have population versus sample, same thing, n over 4n minus 1. But the SS is sum of squares, not just one sum. So you have to do the x minus m and then square that and get the sum. Here are the tiles that we talked about. We had quartiles, which are divided into 4 parts. So like 25, 50, 75, 100. Interquartile is taking the 75 minus 25 to find the range. Semi-interquartile would be dividing the interquartile by 2. And percentiles are just the same as the quartiles, but in percentage.
Up to 100.
Yeah. Standard deviation is the square root of the variance. So when we did the Excel problems, it would be the equals SQRT of the variance that we calculated. It could be of the sample or population. And here are the empirical rules that we have to know is 68 for 1 standard deviation, 95 for 2, 99.7% for 3. And then I think it's the same for skewed, right? These are normal, but this is also true for skewed. That was a question on the.
No, that's just that rule just applies to a normal symmetrical standard deviation. It can be different for the skewed.
Okay. And
That,
standard,
because what that is, that literally makes the curve
yeah,
look like that with that rule with an all distribution. So
right.
the skewed, it wouldn't look like that.
I remember, yeah, I saw a question, something like that. It was like true or false. And standard deviation again is always positive. Computation formula, I always think of you when you do this because you like the computation formula better than Excel. But to know the difference between these, the sum of the x squared is all your x values squared, and you take the sum of that. And then the parentheses are important for the next one because you take the sum of all your values, but then you square that value. So you end up getting two different values, which I thought was like interesting because it looks so similar, but it's two different numbers. And then you divide it by your n to get your sum of squares. And then this is like a preview for the next chapter because I thought about probability. It says, how many do you see? And then Dr. Strange was like 14,605,000. Have you ever seen that movie? Avengers Endgame?
Not that one. I've seen some of the Avengers. Now I have to put on the list.
Yeah, because he talked about how many outcomes did he see to defeat Thanos, and he was like 14 million. So yeah, that's it.
Nice. And that's coming up, by the way. We're gonna get into the amount of possibilities of stuff. That's like a few chapters from now. So nice. All right, who's brave and ready? Oh, sure, Colleen. Yeah, absolutely.
Yeah, so
Where are you? Right
Right
here.
there, yeah.
Gotcha. Okay. If you think you got a venue to share screen on two of them, I'll download it there too. If not,
Oh.
don't. If you think you can, cool. If not, don't sweat it because I can always.
Okay.
It's recording your voice.
Oh.
It's recording all of us.
Oh,
So that way
sure.
someone can hear it. So if you think
So-
there's this or that, either way. If you just click right there and click on, scroll down. And then click on needs, which is fine because there's no grades, just not,
sorry.
not full needs. No, you can't look at that.
Blech.
You can't break any.
Sorry.
It's all right. Don't worry about it.
yeah. So then you do-
It should be like this, needs grading. And then,
so I figured it out last night. I was like, oh.
and you are, I think you're on the second page, right? Colleen.
I'm
Right
right here
here.
in the middle.
Okay, so you're fine. Because I'm screen sharing and if we can make it work, it's kind of, I call it the Wizard of Oz problem. You can go back and forth. I'm trying to open it like in PowerPoint for you. So it shares the entire screen. So, but everyone's doing really. So if you go like this.
Yeah, I think that's what I did.
And like that for this one, and then you just remember to arrow, then it'll record that for everybody too. But whatever's easy, or if you want me to stand up here and help you with that, I can.
I
It's up to you.
I can just.
Okay. All right, cool. All right, everybody, let's give Colleen the floor.
So I like to be a little bit more descriptive in how I learn, and I'm visual, so you'll see a lot of writing and a lot of like pictures. So for chapter 2, I found that was like the one that I needed to look at a little bit more. So here we learn about frequency distribution, simple frequency, intervals, real range, interval width. So for this example, like this would be an interval. Like if we chose the topic class limit, like these would be like the intervals of each, and then the frequency is how often it occurs between each interval. So these are just like the tally of it. But frequency is like the number of times how often a category or range score occurs. So for example, if we chose one, like 90 to 98, it would be like 11, depending on the intervals. Frequency distribution is a summary display for distribution data organized in terms of how often category score ranges. So like example, the average time in minutes it takes for a person to fall asleep. Simple frequency, it's each individual score category, ungrouped data, and distribution or frequency of scores falling within defined groups or intervals, which is grouped. Ungrouped would be like single classes. So if it says like, 2 classes or 3 classes, and then categorical is like if it's grouped in months. So like, June, in the month of June, how many classes or whatnot. Intervals is a discrete range of values which frequency of subset of scores is contained. The real range is the largest number minus the smallest number. And then you add 1 to it. So if we did 468 minus 126 is 342, and then you add 1 to 343, and that's your real range. And then your regular range would be that. Interval width is each interval group frequency, real range divided by the number of intervals. So if 343 was the real range, we would divide it by 7 if that was the interval, and then 49 would be the width. And then you have the upper and lower boundaries, largest value for upper, lower, smallest. And then cumulative frequency, all the different types is what I kind of like had to like group separately. And I use like the book example, which made more sense. So for cumulative sum of frequencies across a series interval, you add from the top or from the bottom. So in this case, it's bottom up. The keywords were less than for bottom up. So less than or below at most, top is greater than, above at least. So here you, for cumulative frequency, from here would be an example. If you start from the bottom up, you would do 3 plus the frequency of 3, which equals 6. And then you just add, you keep adding from 6 to 5, which is 11, 11 to 7, which is 18. And you just kind of add it all the way up, which equals 45 for the frequency for bottom up. And then cumulative percent is a summary display distributes the sum of relative frequencies across a series of interval. So relative would be each of the frequencies divided by the total. So here would be 0.4, 0.5, 0.24, 0.20. And then the relative percent is this decimal as a percentage. And then that would be all of this. And then cumulative percent is starting from the bottom up, kind of like we did here. And you're adding each percent. So 7 plus 7, 14, 14 plus 11, 25. And you start from the bottom up, and it usually equals 100. So that's kind of how I like to look at it. And then of course, relative frequency, which is the proportion of scores in each interval, computed as a frequency in each interval. And then relative percent is just a percentage of the scores. Percentile points and ranks. Score measurement scale below with specified percentage of scores in a distribution fall. And then percentile rank is the score with values that fall below a specific distribution point. And again, I just like to use the book example just because it makes more sense for me to kind of look at everything. So it goes by steps. So if we do like the interval of 90 to 98, you subtract 98 from 90, which is 8. The real range is usually 0.5 below and then 0.5 above. So you have the 89.5 minus 98.5 or 8 plus 1, which is 9. And then you kind of get the percentage of each. So it's a little more in detail, but this is the one I kind of had to like focus on just to figure out how to understand it. And then group data versus ungrouped data. Group data is usually histograms and relative frequency tables. So as you can see here, class interval here, they have it in tally marks and then the frequency of how each occurs. And then ungrouped data is your the data you first gather from an experiment or study, and it's not sorted into categories. So for example, like number of pets is all here, and then frequency is all there. And then these are just pictures. Histogram, usually they're together closely. It summarizes like continuous data that are distributed, which is grouped. Then you got your pi level chart, summarizes relative percent and discrete categorical data into sectors. And then a pictogram is like everything that you kind of see that kind of describes whatever the subject or concept or illustration. So a lot of the times when you see like in the office, like doctor's offices or whatnot, like brochures and stuff that have like pictures that represent what the topic is. And then bar chart, usually separate. Summarize frequency, discrete categorical data distributed in whole units or class. And then frequency polygon, which is continuous data, which is right here. Oh no, here. And then an archive is usually like cumulative percent, so it kind of has a curve. And then stem and leaf in the stem is located in the left of the line. So like, let's say you have a group of this, like 12, 16, 33, 39, 24, 28. The stem is on the left side. So it's usually like the first number. So if we have 1, 2, and 3, it's on this side. And then you usually just put the numbers, the second number on the right side. So this would be 12 and 16. This would be 24 and 28. And this would be 3 and 39. So kind of all that in a separate category. And then chapter 1's my second one. I like the quote that they used in the book where it says, "These are lies, damned lies, and statistics." So statistics is the branch of mathematical use to summarize, analyze, and interpret groups of observation, descriptive, organize and summarize information. So like if we did an example of, we asked how many college or DuPage students drink coffee, and we sent it in an email, let's say, 1,000 students got that email, but we're only sampling 5,000 because only that many people responded. So 73% would be who said yes. So then descriptive is looking at the actual data and saying, all right, only 73% of 5,000 students stated they drink coffee. And then we would use a table or graph to kind of look at that. And then inferential is like interpreting the meaning of, what we're looking at here. So we use population and sample to look at the data. And then data is usually the scores that are gathered, recorded, and measured. And then datum is the single measurement or score or raw score. And then population and sample, which we know all individuals for population, and then samples just a selected group in the population. And then experimental method, which is what we can manipulate, randomize, compare, and control. And in an experiment, it's usually a study that demonstrates a cause can be tested over and over to determine if hypotheses or an experience is true or valid. And then a random assignment is, making sure that each participant in the group is categorized. The independent variable is what's manipulated and changes the dependent, and then dependent is a variable that's measured in the group of studies, usually the outcome. So if we, for an example, if we did an independent variable of, type of treatment and the dependent was blood pressure, we can do a lot of things for the type of treatment. You can lower medication, you can give them a high dose, you can do a placebo and see how that affects the patient's blood pressure. And it can show no change, the blood pressure lowered or nothing, happened. So that's just an example that I used for that. And then quasi, it's not randomly assigned to a group. It's not manipulated, independent. So an example for quasi that I put was like a researcher tests whether disciplining by parents influences a child's attitude in daily activities or if it leads to aggressive behavior. We can't randomize that, nor can we apply that because it's, we don't know, like some parents may discipline their children, some parents may not. So it's not really, can't really say whether they do or don't. It's up, up to the parents. And then correlational is relationship that exists between two variables but lacks control. So again, another example from the book that they used. And then we find that the more people use computers, the less time they spend exercising here. And then continuous versus discrete. Continuous is measured on a continuum. Decimal, we think quantitative. So we can do the key term I associated with it is measured. So we can do weight, height, time it takes to wake up, age, wind speed, water temperature. Discrete is counted. So it's a whole number. So I think of like number of pets owned, number of tickets. There's no like 0.5 or in between. So it's just very like set on a number. Quantitative is data that is measured in numbers. I just think keyword is numerical. So you could say my best friend has one older sibling, one younger sibling. My height is 5'4". She has 5 cats. 50% of people in New York strongly like pizza. Qualitative tells a story. I think categorical. So you think like color of a house, smell of a sock, texture of a shirt. My friend has green eyes. She can be very impatient or manipulative, impulsive. So it's a little more descriptive of what you're, telling. Scales of measurement, nominal, ordinal, interval, and ratio. Nominals identify classification. So we think labels, names, no order. Hair color, a preferred type of chocolate, hair length, short, medium, long, student ID, race or gender. Ordinal, we think rank. We think categorical and ordinal, qualitative and quantitative. It can be both. And then letter grade, rank, satisfaction, salary, sports ranking. Interval, no absolute zero or distance, equal distance between each variable. So we can be put in order. So like a pain scale, time to memorize something, temperature, movie reviews, and then a ratio is absolute zero, equal distance. We think temperature, income, smoking, bank account, chances of winning the lottery. And then chapter 3, the central tendency, population size, sample size. So by population, we represent it by the big N, sample size by the small n, and then the mean and weighted mean. So we do the sum set of scores divided by either the population mean, which is the n, or by n. So that's the formula. And then the weighted mean, we do weighted sum divided by combined. So the book example kind of explained it really well in regards to like you're taking the weighted sum divided by the population here. I guess it gave us like 46, 58, 73, which equals 177. Then you divide it by 3 because that's how much there is, which gave us 59, but that would just be the mean. And then the weighted sum is usually, each score multiplied by the population size. And the example that we watched the other day where the guy showed us everything kind of explained it a little bit better, which I found helpful as well too. So. And then characteristics of mean, if we add a score above the mean, it will increase. If you add a score below, it decreases. If you delete a score of the mean, it will increase. If you delete a score above the mean, it will decrease. Or if you add or delete, it doesn't change anything. So as I was like learning the differences between the mean, the mode, and the medium, like I like to associate it with like color in my head. Like, so I do like normal distribution would be like yellow to me. So that's how I kind of associate it, at least for me when I'm studying everything. I kind of like to color code it to kind of remember better. So for normal distribution, the book has a picture, everything's in the center. It's normal, no skew, equal center. Interval and ratio, differences between two scores, meaningful covariate, interval or ratio scale only. And like, for example, the median would be blue for me. So then in the median, we do, the population or the sample plus 1 divided by 2. So in that example, you count how many there are, which is 5, and then 5 plus 1 divided by 2 is 3. So you move 3 places in. So 1, 2, 3 would be 44. And then the book kind of had the positive and negative skewed. I said the book said positive skewed or below is, below is negative, above is positive, and then key terms I chose to associate with is like mean is greater than for positive skewed, and then negative skewed is mean is less than. And then this one's usually associated with ordinal. So the kind of book kind of showed that there. And then the mode is the data that's set that occurs more often. So it's mostly the one that has like the numbers that's repeated more often. So for example, this one would be 3 because that's the one that's counted the most. And then of course the different modes. So there's moral, which is nominal scale, unimodal, single mode, bimodal, 2 modes, multimodal, more than 2 modes, and non-modal, which is no mode at all. And the key terms often used is most often, typical, or common, and this one's associated with nominal. And I think the book said like patient with schizophrenia are born in winter months would be like a nominal. And then here's just a picture of what the modes are. This would be my bimodal because there's 2. And then summing the difference. The differences of each score from the mean always sum into 0. So this one, it'd be 5 because there's 5 category, or n would be 5. And if you add these together, it's 25. And then you do the total here, or the summation of x minus the mean, which is what you get here. And it's usually 0. And the differences cancel out. And it's always going to be 0 when you subtract or sum the difference. So that's just an example there. And then the summing the squared is taking the x minus m and then squaring it. So it's basically produces a minimal solution, and You subtract scores from any constant other than the mean will produce a greater value. So when we squared it, it gave us a higher number, 54. So that's the equation there, and you just square that. And chapter 4, variability range, fractiles, median, quartile, decile, percentiles. Here, the book gave a good example as far as like Q1 is 25 percentile, which is lower. Q2 is 50 percentile median. Q3 is 75 percentile upper, and Q4 is 100 percentile. And how you find the IQR is you take the third minus the first. So if we had an example of scores of these, the population would be 11. And then you would add 1 and divide it by 2 for the mean, which is 6. So then you count 6 places in, 1, 2, 3, 4, 5, 6, I got 77. And then to find Q1, it scores below that. So you 1, 2, 3, 4, 5 is what I got. So then you do 5 plus 1 divided by 2 is 3. And the third one in is 68. Same with the bottom. Scores less or greater than 77, I got 5. And then I got 87 as the like main 3. So then the SIQR is Q3 minus Q1, which is 87 minus 68 is 19. And then you divide it by 2, which is the semi-interquartile range. Hopefully I did that right.
Your quartiles, and then half of that is your interquartile. So the interquartile, which is your Q3 minus Q1, semi-interquartile basically putting that half again. So quartiles and mean and quartiles and mean really just cutting the last stuff in half, primarily quartiles.
So yeah,
Just
like
over and over again.
in the post test, I was just like, oh my God, I hope I'm doing this right because getting the answer, but I think that's right. So that's kind of how I applied it. And then you got variance, sample variance, population variance, where the data diverges from average squared distance, score moves away from the mean, so negative variance is meaningless. And then sample variance, they use the formula here. So if we had a, sample variance of 26 or the mean of 20, and you divide that by the, 3 would be, where am I at here? Right. So let me go from population, then I'll go to sample. So if we have a population of 10, 3, 7, 8, which is 4, and you add that all together to get your mean, and you divide it by 4, you get 7, that's your mean. And then you calculate the summation of each X. So you subtract each number of these from the mean, and you get a score of 91601, which is 26. That would be your sum of squares. And then you divide that sum by the population, which is 4, and that's 6.5. And then the sample variance would be 1 less. So 26 divided by 3, which is 8.6.
That's right, because your variance, your population, and your sample are close to each other. If they're really far apart, and it depends on how big the numbers are you're working with, you might miss some math wrong, but if they look pretty close, like they do at 6.5, you're probably doing it correct.
And then why do we square, or why square deviations from the mean? If we have a mean of 10, 8 would be closer to the mean, and then 20 would be further away. So it would deviate from that set. And so we measure how far our scores from the mean in a population or sample. And, the goal is the various distances from the mean. And then 3 reasons why we square deviate from the sum of squares is we subtract the summation of X from the mean and then add it together, it creates 0. And then the summation of that's the summation of the differences. And then we square, sum of square differences is minimal, the smallest possible value equals minimal error. So then squaring scores can be corrected by taking the root, provide solution with minimal error. And then I have sample variance unbiased estimator. So bias estimator, they divide the sum of squares by n, sample that does not equal value of respective population, or unbiased, which is sample squared by n minus 1. And then the degree is usually just 1 less than the actual sample. So if it's like 9, the degree less than that would be n minus 1, which would be 8. Or in this example, how they figure it out is if we have 4 and 5, and let's say the mean's 5, we do 4 minus 5, which is -1, 5 minus 5, which is 0. And if we're trying to find this x, we're trying to look for, well, what's going to equal 1, so it cancels 0, so that would be 6. Because 6 minus 5 is 1, so that value would be 6 to kind of equal 0. And that would be the degree of freedom. And the definitional formula for variance, again, I like to color code things. So for me, definitional formula is green. And this is kind of how we all been going about it. So here, population samples 5. And you take the mean 25 divided by 5, and then you just subtract each to get the score here 0. And then when we square that, it equals 54, which is the sum of squares. And then you divide it by the population, which is 5, which we got 10.8. And then the sample is always the population number, subtract 1, divided by 4, and that's 13.5. So I think that's just how we've all been approaching most of the questions in the definitional formula. And then the computational I like better, just because I feel like it's quicker. Here you take your x values, so you got 5 for the population and it equals 25, but then here they square this, so 1 squared is 1, and then you get a total of 179. So they take this score and they subtract it by the summation of x's here, and they square that. And then they divide it by the population. So if it's population, you divide it by 5. So you get an answer of 125 when you do the math. And then you take this score and subtract it by 125 to get the summation, or the sum of squares, which is 54. And then you divide it by 5 and you get the same answer as the previous. So this one you do a little bit more work to kind of get to your answer here. This one they square and then they subtract to kind of get the same answer. I just like this one better. Just quicker for me. And then standard deviation is the same process. You get your answer when you get the summation of squares, and then you just square root it. So we got 10.8 for population, and you square root it, it's 3.28, and then samples is the same thing. You just subtract 1, so you get 3.67. So when you square each, from the example that I used previously. And just a bit of the standard deviation. It's closer to the mean, it's smaller. If it's further than the mean, it's larger. And then we use the empirical rule, which is normally distributed, and then characteristics. So here would be like an example. So this would kind of explain the characteristics of SD. It's greater, always positive, greater than 0, can never be, and can be equal to 0, but cannot be negative. It uses describe quantitative data, numerical values, square rooted. SD, most informative or important when a mean plus or minus 4. So if we had a mean of 12, if we add 4, it goes to 16. If it's less than 4, it goes to 8, and you kind of go above, each 4, 4, 4, 4. And then that kind of gives you like the percentage range it's in. And that's it.
Degrees of freedom n-1 that comes from scores, not the variance in the scores. So if you have a list of scores, the first score doesn't vary and then the rest of them do. So we're accounting for that n-1, so subtracting that one score that doesn't vary. We're doing the sample, or we're doing the degrees of freedom. That's where that comes from. And then bimodal, multimodal. So the difference, or I could have like a whole bunch of them because of the amount of modes that we have. But awesome. Who's ready and willing to go next? Who hasn't gone yet? Can we go, Alyssa? Okay. Cool. It should give me the most recent one, and then if you're able to, and it's certainly not a requirement here, But if you're able to, I'm gonna try to pull up on both screens because I'm screen sharing. So then for the recording, it's better for like anybody that didn't make it to class or anybody that wants to review this. But if it throws you off, it's still gonna pick up everybody's voice, so it's fine. You are right. Maybe at the beginning. Did I just go right by you? No, that's your test. No. Exam one review, perfect, so we'll go like that.
When I did the link.
That's a,
Is
it's
that
it's
okay?
2022. It's absolutely fine. Like, seriously, that's like. Wow. Right.
No.
Right there. Yeah, this is absolutely. So if you go like that and like
So you
that,
said you want me to also change it on here too?
if you can change it on both while you're doing it,
Just press the space button, right? The space bar? Yeah.
just the arrow keys, space bar would work too. Yeah, that'd be awesome. Thank you.
You're welcome.
All right, if you guys are ready, let's give Alexa the floor, everybody. See how she walks us through it.
So I start off really basic. So what is stats? And it's the method used to understand what we observe and the data that we receive. So we went over two types, descriptive and inferential, and descriptive just makes sense of the data we receive, and then inferential allows us to take those observations, just like apply it to larger population. So how I think of this, like population is just everyone. So I think of it as like the whole pie. And then for sample, I think of it like as a slice of the pie. And then for the types of data that we went over, qualitative is descriptive, while quantitative refers to numbers. So quantity, I refer to like numerical values. And that's how I kind of differentiate the two. And then we went over the different methods. So experimental demonstrates cause and effect, and there's 3 requirements, which is manipulation, randomization, and a control group. Quasi is similar to experiment, but it doesn't have a manipulated independent variable, and then it also, or it can elect the control group or both. And so how I kind of memorize this is that if the independent variable is not being changed by the researcher, then it is most likely quasi, I don't know how you say that. Yeah. The IV is naturally occurring. So an example could be like levels of happiness or political affiliation. And then the other one that we went over is correlational, which helps determine if a relationship exists, but it lacks the control to definitively say that there's a cause and effect. So like reliability is consistency. And how I think of this is like, are the results the same when the experiment is repeated and or tested by other researchers? And then validity is just as if it's measured correctly. So then we went over the 4 types of scales of measurement. So nominal, I think of names. An example could be like a sports player's numbers. Ordinal, rank in order. Interval is no true 0, but scales are equidistant. Ratio has an absolute 0 along with the equidistant scales, and it is also the most precise of the 4. For chapter 2, we went over the bar chart, pie chart, histogram, and frequency polygons. Bar charts are qualitative on the horizontal class or horizontal axis. Pie charts show percentages and or proportions. Histograms are classes marked on the horizontal axis, and then frequency shows the shape of the distribution, and it consists of lines. So group data versus ungrouped data. Group data is given in the form of intervals, and it is data that is sorted and grouped. And then while ungrouped data is the raw data, not sorted, and where each frequency is counted and distributed on its own. So to summarize group data, you first find the real range and then the interval width, and then finally you could construct the frequency distribution. For frequency distributions, the different types, there's cumulative, and the keywords that I look for are less than, at most, at or below, and that signals that you're doing a bottom up cumulative frequency, and then greater than, at or above, at least is top down. Relative frequency is the proportion of scores in the intervals. Relative percentage is the percentage of scores in the intervals. Cumulative relative frequency is the sum of relative frequencies across intervals, and then cumulative percent is the sum of relative percentages across intervals, and that total is going to be 100%. Then we went to percentiles, and the percentile point is a score within the whole large distribution. The percentile rank is the percent of scores that fall below a specific score, and then your real range is going to be half of your upper and then minus half of your lower limit. And then the critical interval is the score that is seen as like most important or like most critical. So to calculate percentiles, all you have to do is identify the critical interview, identify the real range, find position of the percentile point, and then lastly, identify the percentile point and the percentile position of percentile point. You're going to subtract point from your top percentage of the critical interval. I don't know why I keep saying interview. So for stem and leaf display, it's a table in which each value is split into the stem, which is the first digit, followed by the leaf for the remainder of the digits. And then each individual score is counted. And then I just put up an example that's helpful to like look at. So for chapter 3, we talk about central tendency, and then mean is just your average, median, I think middle, and then you also have to list the scores in numeric value first before you could just start crisscrossing each value off. And then mode, most is how I think of it. And then I just search for the value that occurs the most. Then we talk about weighted mean. And I was always confused about this in high school because you have your weighted mean and then your weighted GPA and then like your regular GPA. And like, I'm happy that I actually understand the difference between the two now. So to find the weighted mean, you find the product for each group, add the products, and then divide the sum by the total sample size. And then the real world example would be the weighted GPA.
For the, you said for high school, just to like interject, you're doing awesome. Like attempted credits versus earned credits. So like if you take a class another time, you would have less attempted credits and you would have just like the earned credits. So like it would affect like your weighted mean because you'd be taking more classes but attempting less.
Mhm.
So just to like sort of add
Yeah.
what you're saying to make it a little more quick, you're doing awesome.
And then we talked about the skew distributions, and then when does this occur? And it happens when data scores fall dramatically below or above the majority of others. And then there's positively and negatively skewed, and positively skewed occurs when scores are much larger than others, and then they fall to the right. And then negatively occurs when scores are much smaller and therefore fall to the left. And then I just put up an example of like a normal skew or a normal distribution and then the negative and positively skewed ones. And then we talked about the modal distributions. So modal is just one or more. Scores occur most frequency, or I think it should just be one. Or is it one or more?
So modal is just, it can be one or more to be,
Oh,
because that's sort of like your overall, and then you're being clear. So unimodal is just one, bimodal is two, multimodal is
Okay.
several. So you could have one or many, and that's your breakdown.
okay. And then the bimodal is when two scores occur most frequency, and then multi is when more than two scores occur the most, containing more than two modes. And then I just put up another example. And then chapter 4, we talked about variability, which measure the spread of scores. And then a variability of 0 means that there's no variance, while anything greater signals variance. It can never be negative, and then a negative variance is meaningless. And then for the range, it's the difference between the smallest and largest, and it's very informative for data without outliers. So I made everything into steps because I like filling in steps in like math. So I said for the first step to calculate variance, you get the mean of the values, and then you do each value minus the mean. Then you square each x minus m value. You get the sum of the squares, and then you fill in the appropriate formula if you're trying to find either population or sample. And then for standard deviation, it is the distance scores deviate from the average, and it's always positive, and it is always affected by all the values in a distribution, and it is very informative when reporting with the mean. And then to calculate that, you just take the square root for the answer that you got before for like population variance, or the square root of the answer for sample variance to find the sample standard deviation. And then quartiles, to find the quartiles in a set, all you do is find the median for the whole set, and then that's your Q2. And then for the scores that fall below Q2, you find the median of that, and that's Q1. And then you find the median for scores above Q2, and that's your median, or that's your Q3. And then your IQR is just Q3 minus Q1. And then for the semi-interquartile range, you just divide that answer into 2. I think that was it.
How's everybody doing? Do we need a break, or do we want to take a break after we all do the review? How's everybody doing? Kind of like temperature, pulse check, 5 or 10? What? 5? 5 will do it? All right, it's 10:07. Can you come back by 10:12? Get a glass of water, take a bio break, whatever you need, and then we'll do the rest of the presentations. Assignments 3 and 4, probability, and 6 if we have time. So. You might want to email me. I think you walked in late, just email me for attendance. It doesn't affect your grade, but DuPage looks at like how often you're here for like adding and dropping students. So I only think it has for that purpose. You're probably fine. You're here, I want it to count. But it doesn't affect your grade at all. I just don't want them to do some weird dropping thing, which we can fix. It's just a pain, because then it's like, why were you not there? And I gotta send a bunch of emails and just shoot me an email. So
Okay, I'll do that.
the same for you if you walked in late, just I mean, I think you were here on time though. Yeah. No, feel bad at all. No, just, no, like it doesn't count towards your grade at all. It's just financial aid purposes and like staying in the class. If you're not here frequently enough, the admissions people that clearly don't know what the heck they're doing, or maybe you have more success with the supervisor. I'm just trying to protect you guys from that. It has nothing to do with your grade. You could skip all semester and it'd be fine. And if they dropped you, I would fight them and we would get you back in class and I would win. If they dropped for non-attendance, I've won that battle with DuPage before with students. I'm just trying to make your life easier.
They can do it.
Yeah, they can, because it's a face-to-face course. That's why I take attendance, to protect you guys. So you're here, but I can take attendance like in the past if you email me, or if you're like, hey, Dr. Mack, I watched a Zoom recording. I'll mark you like you were here. Like I can modify that. So if you're like, I can't be here for 2 days for whatever reason, and maybe like send me like a summary of like, hey, I watched the recording, I learned this and this. I'll make it look like you were here. So I'm not gonna, it's never gonna hurt you. I just don't want to like administratively have them do something weird with students. And it's not coming in late once in a while. It's not even skipping a class. Is if you're out for a long period of time, that's when they like mess it up. And I'm just, because they have some random, they look at like, I think the percentage you attend or something weird.
But it's just it was me and Vale who were like having like issues with what's it called, with the Cengage.
With Cengage, so I've been emailing them and I've been CCing you guys, or if you've emailed me, I have a person that I'm working with that can fix it. I think Valentina emailed me. If you email me, I can deal with that right now on our break. But all I need is I just need you to say, I'm in your class, this is my problem. And then I'll take that and I'll hit reply to all, put somebody in on Cengage and she'll be able to fix it.
Okay.
So I have I'm helping Valentina with it right now. And
Because I was gonna buy like again, like
no, you're not, you're never bothering me. I'm here to foster student success. I'll talk to you after class as long as you need me to. For selfish reasons, I probably want to try to get to the cafeteria by 2 so I can grab something to eat. But if you need to talk to me till 3, I'll just grab something at home or get my wife out to eat or whatever. So it's fine.
Since tomorrow, like I have like nothing to do basically. can we make like an appointment? Like,
Yeah, we
set
made the
it-
face-to-face or Zoom and I'll help you. And I got half of mine to go down to ask commissions, like, what the hell? Like, seriously, like, get your shit together, people. Like that irritates me.
Oh,
Like, seriously, like, they should have that together. Like, And then, come on. And then what'll end up happening is I'll just grade over the exam 2 submission. It's no big deal. So just so there's a spot for it. So if you see that, like, don't freak out. It's no problem at all. It's just, I can't give you credit for both spots,
Yeah.
but the grade will override it. So you're totally fine. But because there's a queue, I have to like grade something. Just so that like it's cleared
Does that
out.
one,
and
like, actually work or no?
What?
Like the microphone?
It does work, but I didn't grab the right cord this morning.
Oh,
But there's a microphone built into this.
oh,
So we're still picking everything up. Like as long as like, I mean, like right now it's probably picking up everybody, but I usually plug it in. It gives us, it's slightly more clear, but if you're like in proximity to the podium, it's gonna pick you up for sure. Plus, if you're able to, and it doesn't like mess you up, what I've been asking people to do if they can, is I pull them on both of these, and then if you can like, just hit like the space bar or something. Hang on, I don't think I'm sharing yet. It'll make sure that like for the recording purposes, like everybody can like see it. So,
So I'm just.
so
guessing,
like, so you're
that's
just,
that right? Oh,
so what I'm saying is like, play. So like, if you can go like that or that, like if you remember, if you don't,
Oh, okay.
don't sweat it. My idea was that like, for the record, for any of you to review it or record, you could actually see it and hear each other kind of simultaneously if you remember to do it on both of them. Because that's the one that's going to show us that. All right, let's give Gustavo the floor, everybody. You ready? All right, let's do it. You walk us through. All right, cool.
Chapter 1, descriptive. The following data is summarized and organized. Examples like graph, table, etc. And inferential is like interpreting the information. The sample is the representation of a subset of a population. Population is a set of individuals. What are the scales of measurement? Nominal, basically the classification like dog, female, male, or even horse. Ordinal is this scale is basically a ranking, like a ranking of the top 10 best soccer players. Interval is order and equal units. As an example would be the SAT score. Ratio includes order, equal units, and absolute zero, like weight. Discrete or continuous represent measurable amounts like water, volume, or weight. Discrete represents counts like the number of Hot Wheels in the package. Quantitative versus qualitative. Quantitative is this is the number of base data or measurable. Qualitative is this is descriptive interpretation or documents. Chapter 2, group data. The frequency of each score fall to any interval. Interval range of values with the frequency of subset of score. Group data. Range, having to get the biggest value, subtracting it from the smallest. Real range, in order to find the range, you just grab the total from the range and add one to it. Next step is just to grab the total number from the real range and divide it out by the number of intervals in total. Relative frequency, in order to find the relative frequency, you just need to divide each frequency number by total sum of the frequency, getting to have the relative frequency. Percent, after finding the frequency for each value, you will need to find the percentage, which you just multiplied by 100. Both cumulative percent and relative frequency are just added with the top to bottom or the other way around. Percentiles and quartiles. Percentile number of values below X. It is the number of values below X divided by the total value times 100, which will give you the percentage. There's only 3 quartiles, which are 25%, 50%, and 75%. Histogram is summary frequency of continuous data. Frequency polygon, a graph that uses lines that connect with points for the frequency at midpoint of the classes. OGIV is graph that represents a summary of cumulative percent of a continuous data. Bar chart is summary frequency of discrete and categories. Stem and leaf display divide presenting a quantitative data in a graph like the histogram, which is to help see the distribution. And the pie chart is just like a summary percentage of the discrete and category data in 2 sectors. Chapter 3, population. Mean is like the lowercase m. Simple mean is a big M. Mean is where all the values are added and divided by the total value, which both sample and population are same, just different notation. Median. In order to find the median, you need to set the numbers from biggest to smallest, and the number in the middle will be your median. even if it was even, you just need to add them both and divide it by 2 in order to find your median. The mode, in order to find the mode, you just need to put the numbers in order, and the number that appears the mode will be your mode. Characteristics of mean, changing a score will change the mean. Having to add, subtract, or divide the score in the distribution will cause the mean to be changed. Sum of differences by the scores of the mean will equal 0, basically grabbing one of the x value minus the mean. The sum of square differences of score from the mean will equal minimal. In order to have a value greater than 0, you will need to square the deviation. Chapter 4. Range is just taking the largest value minus the smallest value. Divide the data by 2. Having to look at the interquartiles, you need to first find the median, then later on find the 2 interquartiles on each side. In order to find the IQR is by having Q3 minus Q1. To find the SIQR, you will just take your IQR divided by 2. Variance is calculate the sum of squares first, then divide by the denominator. So the y squaring is deviation in numerator. Each deviation squared in order to produce the smallest positive solution. Squaring deviation creates a solution with minimal error. Scores can be corrected if doing the square root. And then the computational formula for variance is just the SS divided by N, or for the sample one, it's just the N minus 1, basically. That's pretty much it.
Yeah, thanks. Right, we have, okay, yeah, I think we got you, and then jump over here, so let's grab, where are you, you're right here. Okay, I got that. That even worked? No, it did not work. Hang on. Share. Review. Share. And now let's go over here. Right there. Perfect. Chapters. Okay, so if you can remember, just scroll on both of them. And like this is a Bluetooth mouse, even better. If you don't remember and you just do that one, it's okay. It's just for the recording. If you can do it, great. If it messes you up or messes you up, you don't need to sweat. Okay.
Okay, I'll try.
All right, everybody, let's give Ilona the floor. See how she walked through chapters 1 through 4.
So mine aren't like they don't have much words just because I'm more of a kind of you have to do it to learn it type of person. So, but for chapter 1, I did the vocab. So the ones that I kind of like had a hard time remembering was a nominal, ordinal, and then interval variable, also with the ratio level of measurement. So for the nominal, I just said that it was like labels and names. So you use like it's kind of like a label, like it says.
A label or an adjective.
Yeah.
It's gonna be nominal all day long.
Yeah. And then ordinal is a numerical valuables that are ranked. For example, I use like salary, grades, and class ranking. The interval has no absolute 0, and then there's equal distance between the variables. So I said like a 1 to 5 rating, 1 through 5, there's equal distance and it doesn't have 0 in there. And then for the other one, there is the absolute 0. And then again, it has the equal distance. So it's 0 through 10. You could use 0 as being like the worst, to 10 being the best. And then for these ones,
Like y'all should clearly use a ratio or a ratio instead of interval, right? Wouldn't it be better for y'all? Wouldn't that be way more accurate? The problem is using interval
yeah.
variables.
And
You wanna
then
do-
the continuous, it just measures along a continuum. And then discrete separates and is individual categories. And then quantitative is just varies by the amount of the variable. And then qualitative varies by the form or the class of the variable. And then frequency. So a frequency table is qualitative. So I have the tables up here kind of to describe it. And then frequency distribution is quantitative. So this is the distribution. So you can see it kind of just like goes out in its own ways. And then the qualitative is just like the table, the numbers, rather this one it's kind of put out in the graphs. And then I did how to find group data. So for the first step, you have to find the real range. So you just find the range and then you add 0.5 and subtract 0.5. And then after you do that, you find the like interval width, which means you divide the real range by the number of intervals chosen. And then and then for 3, you construct frequency distribution. So that one is the same number as the previous step. And then I did theories and variables just because I thought this kind of like helped me kind of just explain, well, understand stats better. It's like if this happens because of this. So conceptual variables are just like the concept. So which I think it would be down here on this example.
Can you pull it up for us? Or I can
How
show
do
you?
I do that?
I'll show you. I just think because it's so small,
Yeah, it's hard
I
to
can,
see.
like not quite see it. So it should be
Oh, just there.
right here. And then the more you do that
Okay.
or scroll, the more we can kind of like see what you're showing us. Can everybody read that? Is that better, or if you need more? Okay, cool.
Okay.
Keep going. You're doing awesome.
So the concept would be like so I think this was like for a business company and they were trying to achieve a certain goal. So for the concept, it would be down here, the people that are working for them, the technology they use, and other assets like their finances. And then for the operational, it would be the processes. Yeah. And and activities. So it's like what they're doing to get their goal. And then for the measured variable is just like the variable up at the top, meaning what they're trying to achieve. So the mission and the business results. So based on how they do down here and what they do for their activities is what they're going to get up here, if that makes sense.
So like, you're doing awesome. So operational definition criteria would probably be your KSAs, knowledge, skills, abilities, versus your measured variable, like what's actually happening, like your outcome. So any company's knowledge, skills, and abilities to achieve their goal of their employees. So it's like, what can you do? Like, what's like your working knowledge of what you're doing, like sort of conceptually, what can you do to actually get the job done? And then like, what's your ability or potentially your superpower, like what you're good at?
Mhm.
Knowledge, skills, abilities, KSAs, that would give you like, just more of like an overlay of like a business psych, IO psych version of looking at that. Doing
Yeah.
awesome, keep going.
And then for
And you
this
can zoom
one,
out right there, yeah.
Okay, and then this one, I just like did an example for mean, median, and mode rather than just kind of like putting the definitions. So the mean, you add them all up and then divide them. And the median was 4, and then also the mode was 4. And then I don't know why, but I just put probability in here. So I kind of did the example that you used because I feel like that was the easiest way for me to actually understand it. So I said there's 3 dogs, 4 cats, 2 birds. And then what are the chances you pick a pet cat over a dog or a bird? So there's 4 cats, and then there's a total of 9 different pets. So you do 4 divided by 9, which gets you 0.444, which equals to 44.4%. And that's all I really did.
All right, I think we just, yeah, you two and you were, yeah, you want to go next? That would be fine. Nisha. Yeah, we grab, where are you? And let's go like that. And let's stop the share. And then assignment back. Where are you? Right here. Maybe talk to you like sidebar about straighter line. Yeah, that'll make sense later for sure. Straighter line. So you know what that is? Straighter Line is a company that lets you take math and science courses online, approved by the American Council on Education. It's more for like the nursing folks. It costs a fraction of the cost of you take a course anywhere else, but it's self-paced. So if you take a long time, it can be the same or exceed it. But like if you're dissecting like a fly, you like click. So they have lectures and labs with math and science, but it doesn't always transfer. It depends on the policy of the school. So if you want to get your feet wet before taking traditionally cool, if you want to transfer it, possibly, but it depends on what the school's policy is. Sometimes they say yes. Sometimes, like I used to advise dental assisting students, and they needed prereqs to get into some of our science courses. So we took it, but I let them do that so they could like have a faster trajectory. But not every school takes them because it's a company. They're not regionally accredited, but no, it's like 100 a month or something, or 50. Like it's super affordable. It might be comparable to a course here, but if you're trying to save money or you need a course here or there, or it's a course that isn't offered, but talk to your admissions person about, will you take this before you take it so you don't do. What was that? I can get the spelling, yeah, just straighterline.com. Straighter,
Okay.
yeah, I can write it down.
Thank you.
It's absolutely no problem at all. So actually set that up here. Zoom share, that's yours right there. So if you remember, and you can do both of them, great, because we're screen sharing. If you space it and it's just your voice, it's fine. So it's the arrow or the space bar key, or you can like click on the mouse or go like that. And this one, it should be the arrow, the mouse, or it should be the, I believe it's the space bar key on this one too. Yeah.
Space.
Space for both. If you remember, if you don't remember, not to be, I'm just trying to set up the recording.
Okay.
It's you presenting. All right. Anisha, right? I'm saying it right.
Anisha, yes.
All right, everybody, let's give Anisha the floor. See how she breaks it down for us.
Okay. So mine is pretty basic. So I started with statistics. It's a set of knowledge used to summarize, organize, analyze. I keep forgetting the names. So I kind of, keep that SOA thing in my mind so that, I don't know why I keep doing that, but anyway, it's used to evaluate scientific evaluation data. It's usually numeric. It is a set of measurements or observations. There are 2 types. One is descriptive. It's used to summarize, organize, analyze data. Inferential, it's to infer meaning from samples. More terms, population, entire set of data or items of interest. Data terms as parameters. Sample, it's a portion of population, and the data is termed as statistics.
Or stats?
Yeah,
Stats.
it's
It's short.
tongue twisters. Qualitative data, it tells a story, it's descriptive. Quantitative is number related. Different research methods, experimental, quasi, and correlational. Experimental has cause and effect, manipulation, randomization, and comparison control. Quasi doesn't have the manipulation or control and does not change. So like the example is age, that doesn't change. Correlational, it's got two variables, X and Y, and the relationship between them. Reliability and validity. Reliability is consistency. We get the same answer over and over. Validity is measuring it correctly. So we can have validity without reliability, because if we measure it correctly, we can probably do it again and again. I went into single blind. The participants do not know who receives the treatment. The observers do. Double blind, both of them don't know. Independent variable. I had an issue in the beginning with that. I was like confused. Independent is we manipulate the terms, and dependent is basically the outcome, and the values can change for independent, and independent the values cannot change. It's like we did the Java experiment, and the coffee is the independent variable, and the grades that we get, if you take the coffee thing, is basically the dependent. Scales of measurement, again, acronym NOIR, NOIR. Nominal doesn't have any order. It describes stuff. Examples, zip code, race, gender, ethnicity. Ordinal is basically ranking. So the space between the variables does not matter. Examples, class rank, grades, etc. Interval, it doesn't have an absolute zero. Equal distance, and examples that I wrote was survey 1 to 9, where 1 being the lowest, 9 being the best, or Netflix ratings. Ratio, absolute zero. Equal distance between the variables, and example is I got was number of cars in a family. Types of variables, continuous, it's measured along a continuum. It can have a decimal point. Examples, weight and height. Discrete is whole numbers, like number of siblings, gender, etc. Quantitative, it varies by amount. Example, food intake in calories. Qualitative is non-numeric, it's basically labeling behaviors. Categories of depression, that's the example that I gave. Chapter 2, frequency distribution. I am not quite strong in this chapter. There are a lot of terms which is kind of confusing. Not these, I'll get it. Frequency, number of times a score occurs. Frequency distribution is summary of how often it occurs. Simple frequency, it's sorting out in groups. I think group data, set of data in intervals, and I forgot what the ungrouped. Ungrouped is basically the raw data that we get. Interval, discrete range of values. Range is the largest number minus the smallest number in a set. Real range is basically the range plus 1. Interval width is real range divided by the number of intervals. Interval boundaries, upper and lower boundaries in grouped frequency distribution. Lower boundaries is the smallest value. Upper is the largest value. Open interval, it doesn't have any upper or lower boundary. Outliers are scores which is like so far out. Cumulative frequency distribution, it's sum of frequencies in a series of intervals. So terms like less than, at or above, at most is at from bottom up. Greater than, at or above, at least is at top down. Relative frequency distribution, observed frequency divided by the total number of frequency. Relative percent distribution is observed frequency divided by total frequency to 100 so that we can get the percent. Okay, this is my weak area. The cumulative percent distribution, I kind of have an idea, but I don't know how to explain it, nor can I don't think I can do a problem. So that's like.
So I think today, when we do 3 and 4, and we practice, that'll make that clearer. If you're still feeling unclear, I can add more activities or more stuff.
Yes, please.
Or find another way to go through it. But I think when we actually do it today on Excel.
Yeah.
I think we'll probably have time for both probability and that today.
Okay.
That should be clear. And I'm gonna give you guys until Wednesday at midnight of next week. So we'll literally have a week more of not only new material and or the possibility to review. So that way you have time to be super clear on it. And like I've said from the beginning, if any of you need to be one-on-one besides class, you just gotta tell me. And that can be face-to-face or virtual. I just have to know, and I will absolutely make time for all of you have a review session or whatever. Just don't wait until the 11th hour on Wednesday and say I'm still unclear. Like, don't text me at like midnight. and go, No, but hopefully the practice state will solve that in terms of how we calculate, how we get there. If it doesn't, you just gotta
Yeah,
tell
probably
me,
a.
and I'll work you one-on-one and or the class if I feel like, or you all say you're not clear on it. We'll get you there before you do a test at all.
Because I think that the problems would probably help.
The
you know.
problem will probably help, but if we need to do more than that, I just need you all to tell me, because I don't know if you don't tell me.
Okay.
So. The exam is in Blackboard, 2 attempts, a limited time, and I'll give you until 11:59 on Wednesday of next week. So you can have an entire week to make sure things are clear rather than say, hey, it's due by the end of the week. If you want to do it before the end of the week, you can. Again, highest score, 2 attempts. So you can try it before Wednesday. If you're like, hey, I'm really stuck, this isn't really making sense. You could say, I missed this stuff on exam 1. Send me your questions, bring them to class, email me, etc. Now, if you tell me in advance, I can prepare something to go, these things are unclear, here's another activity we can do points or not, so that's clear for everybody. And like I said, we're gonna cover it, they will probably make that clearer for you. So yes, Gustavo, you have a question? I think it's 50 off the top of my head. I can go in and look, it's a test bank, I think it's about 50 questions. I can double check. No one gets the same test, by the way. All the answers are randomized and the questions are randomized, and I test content. So if you fail it or ace it or B or C or wherever grade you get the first attempt, then it's not like the pre-test and the post-test where it's a lot of the same. It's the same content. It's going to test you on frequency distribution, cumulative relative frequency, etc. But test 1 and test 2 will not be identical. But if you brought your questions or concerns to class, if you took that attempt, you could probably do better on the second one if you need to. So like I said, I think that'll probably be clearer today, and that's fine. That's great. Then I know what to review if we need to. Just please talk to me, everybody, because I'm rooting for you to end up with an A or B in the class, but obviously you get the grade that you earn. Go ahead, Carlos. The 2 tests are different. So exam 1 will be the same exact content. Like it's gonna be chapters 1 through 4, same terms, but it might be like a different problem. You're not going to get problem on test 1 to be the same on test 2, but it'll still be the same content. Does that make sense? I answered that clear? Okay, cool. Well, you're doing awesome.
Okay, this one I named it wrong. It's not pictograms. It's supposed to be like graphs. Pictograms is like the pictures you see in hospitals and stuff. I did this at night, so.
That's okay.
Histogram, it shows the frequency of continuous data that are grouped. So it's more like together. Frequency polygon is a dot and line graph, continuous data where the dot is the midpoint. OGIV, not really strong there. OGIV situation, dot and line graph, I just copied it from the text. I'm not sure of that. Stem and leaf plot, I didn't know it. I checked with Colleen, I kind of know it right now. It's okay now. Stem and leaf plot is common scores is the stem in the left and the other scores are the leaf. It didn't make any sense then, but she can explain it so I can know now, because the smaller, if you take a number, the smaller numbers go to the stem and the bigger numbers go to the leaf.
Yeah, it's just listing.
Yeah,
It's just a way of like listing the information with stem and leaf, which is, it's kind of unusual, but that's literally what you just said.
Yeah, I thought it was like, I was getting confused because it's the numbers like 13 or 14, 15. I didn't know that you have to like take the ones and put it in the stem and 2, 3, 4 and I was confused with that. So it makes sense now. Okay, next is bar graph, which is basically frequency of discrete data. It's different. I mean, it's not like close together. Pie chart is basically a circle, summarizes relative percent. Next is chapter 3, summarizing data, central tendency. Central tendency is to find a score which represents all the scores in a distribution. And a capital N is a population, small n is sample. Mean is sum of scores divided by the number of, basically the average. Population mean is mean by population, and sample is mean divided by sample. Weighted mean is combined mean of more than one group divided by the number of scores. I don't know why I wrote check there. Median is middle value of data set used to describe ordinal data. Yes, okay. Ordinal data and skewed distribution. Mode is the most frequent value. Yeah, I don't know how to word the question, but I'll get you.
Okay.
This is a bell-shaped distribution. It's bell-shaped normal distribution. Scores are uniformly distributed. Skewed scores in the distribution fall far above or far below. So in positive, the mean is greater than the mode. And negative, the scores are below most of the other scores. So mean is lesser than the mode, yes. This is normal distribution. All of them have the same value, mean, median, and mode. Modal distribution, unimodal, it has one mode, bi has two, multi has more than two, non has like no mode, it's like a straight line. Chapter 4, readability. Measure of spread of scores ranges from 0 to infinity. It always has a positive value. Fractiles basically divides the data into 2 or more equal parts. Quartiles is like 4 parts. Lower is median value of the lower half of the data. Median is like the midpoint. Upper is the upper half of the data. IQR is values between upper and lower. So Q3 minus Q1. Semi is Q3 minus Q1 by 2. Variance, estimate of variability. Population variance is sum of squares by population. Deviation is x minus m, where x is the value and m is the mean. Sum of squares is sum of x minus m raised to 2 square. Sample variance, sum of squares divided by n minus 1, where n is the sample. Degree of freedom, I missed this class. I just know this number of scores that are free to vary, and then minus 1 standard deviation, square root of variance. And I did not do, thank you, this is it. I did not do the computational formula because I missed the class, so I don't really know. I just checked with Kate, so I
And I
didn't.
do have up from 20 is posted
Yes,
in Blackboard. By the way, under lecture
Yes.
recordings, I recorded the whole thing, and
I saw it
I'm
later.
pretty sure there's just a screenshot for most of the time.
I saw that later after submitting this, so.
No
yeah.
worries. Yeah, that's fine. We submit or something, that's fine. You covered 98% of it. So.
Thank you.
Gentlemen, who wants to go first? Okay. Okay. Second, Nick, you are right here. I'm gonna see if I can grab it off here. If you remember to use both screens, wonderful. If you forget, not the end of the world. I'm just for like recording. I'm trying to have the screen share so people can. Arrow keys are space, but like really for this, the best way to do would be like download it and then open it right here, because then we can go like that. And then for this one, right here, like that, like that. Okay, so that should open in a second. I got like 2 gigs on this computer, but I have like 8 megabytes, so like it doesn't always want to open. And Apple fuses it, so you can't get it to move any faster. All right, so here we go. There's that. So if we go like slideshow, play. So if you remember, do both screens if it messes you up. And it should, so it should be, you should really just like
Click it and then
click it,
just-
or you can also scroll with like this. Or you can go like that, or arrows should work too.
Oh, it's left, okay.
Arrows working, I think spacebar does too.
Okay, yeah, I think I'll just use the,
Yeah, it should be about the same on the other.
arrows down.
All right, everybody, let's give the floor to Nick. Let's, walk through it, and then Jonathan, and then we'll take a break, and then do some more stuff here, so.
All right, so chapter 1, independent and dependent variables. The independent variable is something that the researchers are manipulating, and I would change what I wrote for dependent. It's the result of what you get, and the idea I use always is just like researchers with how much sleep and will it impact your results. And sleep is something the researchers will change. Some people get 6 hours, some people get 8 hours, and then the dependent would be whatever result, like an A, a B, or whatever. Quasi-independent variables are things that are already kind of set and you cannot change. Political affiliation, religion, things like that, that researchers aren't really going to be able to change. Okay. Oh, shoot, that's on that. Oh. Population versus sample. Population is the entire group. So I just have like all the people, say in America, who are conservative, and the sample is a subset of the population. Maybe we survey or study 5,000 people who are conservative. So just a small subset of a larger group. Nominal, ordinal, interval, and ratio. So nominal is a description of things. An example would be a person's age or sex. Ordinal, the ranking of things with equal units and no true zero. So the Payne scale is an example I think of. Interval, equal units, no true zero. What, really quick, what is the difference really quick between ordinal and interval? Because sometimes
So ordinal is like ranking and not necessarily equal spaces between each thing. It could be like decimals, like it wouldn't matter. And then the nuance is interval, equal spaces, and no true zero. So when we say nominal, like it's an adjective, like it tells us something, it can be kind of vague. Like if I say I drove here and it was hard because there was a lot of fog, it was soupy fog. You have an idea what I'm talking about, but it's still kind of vague. And then ordinal, like that's that ranking, but then again, they could be the same distance, further distance from each other. And then interval, they have to be the same distance. No zero, ratio is going to be absolute zero. So interval is either no true zero or an arbitrary 0 point, whereas ratio actually has like definitive on the 0 point. Does that help clarify that?
so wouldn't my example of like interval like 50 to 59, 60 to 69, does that work as an interval? 'Cause
Yeah.
that's- Okay.
Yeah, but like in your interval, you would never have 59.5.
Yeah.
And then 60.7.
So
You
that's
know, you
good.
could, it has to be the same amount of spaces. Like you don't move into the suburb and have 2.3 kids. Right? You have 2 or 3, so.
And then ratio, equal units, and has an absolute 0. So I use the example, the numbers of dinosaurs around, or it could just be humans, like there's only a finite number of humans alive. Discrete versus continuous. Discrete values are those that can't be divided or have fractions. An example would be how many people died today, and or like how the kid example, right? You can't have like 2.5 kids. You can't have like 20.5 people dying. 20 people died, 21 people died. A continuous data can take any value within a range. An example would be at age 5, you're going to be a different height than at age 15. It's something that can change. I don't know who said it, someone earlier, but continuous, like it continues. So
It's usually like there's not necessarily like a stopping point.
Mhm.
Now, with height, might argue it could be discrete because I think the tallest person in the world was 11'1". He was 6 when he was 5 years old. He was 6 feet tall. By the way, so I'm sure there was absolutely sure everybody was like respecting. He was 5, he was 6 feet tall. Whereas like income for continuous data, so he died when he was like 21. By the way, because because there's his height problem with kept growing, like that's what actually killed him. He was 11'1", tallest person in the world. Continuous data is like income because it's kind of unlimited and it can kind of like go not really into infinity, but like keeps going. So discrete's usually like a very set value, or like you're talking about like the number of people that died. Dark example of works like COVID, right? People died from COVID probably, right? And then like continues to kind of go like on and on, there's not necessarily a stopping point. It's definitely like less clear than definitive, like it just can't, like discrete, like it keeps, it is usually like, keeps going, and this height isn't a bad example because it can totally like vary, it doesn't necessarily stop.
Yeah, because I remember when I was looking it up, it used, like I saw height as one of the examples, but it also said like within like a realistic kind of range, I guess, of like, obviously like someone can't be like 100 feet tall.
Yeah, like
or
someone can't
something.
be tall, that's, because that would, yeah, but in
But-
a realistic range.
Yeah,
It could absolutely be continuous, and also it's gonna be like, you know, 5'1", 5'1.25",
Mm.
all the way up to like, you know, what, 6'5", maybe 7 feet, most people at the most, so yeah, that's the idea, yeah.
oh, chapter 2. Not too much.
Probably a transition.
Yeah, I didn't fill those out too much. Okay, cumulative frequency. Find out how many values there are above or below a certain data point. So the example that I came up with was the number of students with at least a C in the class. And that would be bottom up or bottom
It
down.
depends on how you go. Bottom up, you start at the bottom of the grades up to the top. Top down, you start at the top and go towards the bottom.
Like with the wording, like with at least.
I think it's at least, most, and
then-
then I have to look at my notes for the other one, but there's keywords.
Yeah, to
that
differentiate.
that can do that. I could go over that. I just have to look at that again.
Okay. Okay, so relative frequency and relative percent. Relative frequency, find out how many times a certain event takes place throughout your data. An example, your team won 6 out of 8 games, giving you a relative frequency of 0.75 for games won. And then relative percent, you find the percent of the relative frequency. So if your team won the 6 out of 8 games, your relative frequency is 0.7, then you multiply it by 100 and you get 75%. Okay, chapter 3 coming up. Central tendency is a value that occurs the most. I just think of a bell curve or this little picture. Just like most people fall within that range of central tendency. Okay, unimodal, bimodal, multimodal, and non-modal. So unimodal only has a singular mode. Bimodal has 2 modes. So like this one, it's bimodal. Multimodal would be like this. And then non-modal has no mode. So that would just be like just like a line kind of across. Okay. Quartiles. Okay, so they're split into 4 equal parts. You have Q1, Q2, and Q3 with the percentages. Okay, locating quartiles. So you find the median, which I stole this thing from the PowerPoints because it was really helpful for me.
Like I said, you're fine. The whole idea is like not to just completely like cut and paste everything out of my PowerPoints. If you take some stuff and make it your own, fine.
Yeah, I like this one a lot because it's just easy for me to understand. So the median, you just keep like cutting down the numbers so you get into the middle, and you have 85 and 87, so it's 2 numbers. So you got to add them and then divide them by 2, you get 86. And then if you want to locate what is Q1, you're going to do pretty much the same thing, starting at 62 and 85, and you just keep going until you get to 76. And then for Q3, you start at 87 and then 98, and then you get down to 92. Finding interquartile range and semi-interquartile range. So for interquartile range, Q3 minus Q1. For the previous examples, that'd be 92 minus 76 equals 16. The purpose of it is to get rid of outliers. And what, so like we got 16 for that example. Like, what does that kind of show us? Like, what would that indicate, I guess?
So we're just looking at like the range of the quartile. So it's really just like descriptive data.
Mhm.
So depending on what you're looking at, we want to think about like maybe something like with behavior, maybe in psychology, or like you might say, we found the data of, between, like, let's say you get a new manager or you get like a new leader, or there's a new organizational change, and then many like employees like meet with resistance, like they don't cooperate or they sabotage the work or they cooperate. You might talk about like the range of that. So the idea is we're looking at psychological data. We're talking about like, what does a behavior show us? So this would just sort of be like within these. So we talk about like resistance, let's say like resistance to like the new leadership, like I had a boss who's like a bully, like just I can't even believe they like gave him the job. But he got along really well with the boss's boss. That's why they hired him. So let's just say we have a bunch of employees that are like resisting the organizational change. Well, the outliers maybe are people that are like cooperative. There's not many of them. So the idea is with the quartiles, we're trying to get like a reflection outside of like the central tendency or the mean or the median of that, and like show us something about it in terms of like what the behavior looks like. Does that help explain kind of like what we're cutting it in half? We're looking at like, here's our mean, but also like what are most of the people doing sort of like in the middle of the behavior. So it's like it's a way of looking at not really necessarily the average, but like the range of what's going on with whatever you're studying. I hope that's helpful. If I'm thoroughly confusing you guys, you can tell me, or I can think of some more examples that would be helpful.
I think so. Just you're trying to figure out kind of just like even within that average spot, like where people fall within the average spot, pretty much, or
Yeah, well, it's kind of, well, remember the median removes the outliers,
Mhm.
so it's more like a range sort of like outside of that. So you're just trying to say like where people fall, like where, like that's kind of like middle behavior, like what's everybody kind of doing. Salaries too. The average is great, but then like the median point of salaries, that's usually whatever. A lot of times it can be more accurate because you have a few people at a really high salary level on your average. It doesn't really tell you what's going on with behavior, but if you do the median, he gets rid of those outliers, and then you can be like, well, the median of the area, most people are getting this amount. Why would I get anything different? It's not even like an average. Actually, the median's actually more accurate because we don't have sort of the left and the right, low and highs point on it. Does that help?
no, yeah, okay, that makes sense.
Okay.
And then the semi-interquartile range. To find that, you need to divide by 2 your interquartile range. So we had 16 for our IQR, so then we get 8. SS, sum of the squares, population variance and sample variance. So to find the SS, you got to find the mean. Then you minus out of the values you have, like we're doing on the Excel worksheet. You minus the mean from all the values you have, and that's when you kind of get like those negatives and some positives. And then you square all the individual numbers. And then once you square all those numbers, you'll add them together, and that will be your SS. That was right.
Yeah.
Okay,
that's
cool. I
right,
just
yeah.
wanted to make sure.
Yeah. X minus M or the other, they're probably computation form, either work, you get the same number.
Mhm.
I like the one with the extra steps, just like computational is fine too. And then just make sure you don't do anything with that sum, because that is your sum of all of your squares. Like don't start doing X minus M with that.
Yeah.
And then you divide it by N or N minus 1.
Yeah, and so then for population variance, what you're gonna do is just take your SS and then divide it by all your number of people in the experiment, or just the numbers you have, so like divided by 20. That's how many different variables you have. And then for sample variance, you're just gonna do pretty much the same thing, SS over N, but then minus 1. And that's the end.
Oh, that's it.
Awesome.
Perfect. Yeah, you can zoom in if you need to. I'm just gonna try to, I'm trying to pull it up on both.
Yeah. So
If you, if you can remember, just like, so that they match, because then it'll just make the recording for anybody that either missed class or maybe that want to review better, because then you can see the visual, what you're all talking about. Let's go like this. So that's open. Let's do Zoom, share screen, exam 1 review, share. And then this one, if we go like this, we open it like that. That's gonna be better. So here's your mouse, here's that space bar, keyboard, and then of course, obviously for zooming in, you got the 100% at the top. So.
You do both at once.
You remember, it's wonderful because it's. No, we'll take a break after this, by the way. Got about an hour, so.
Yep, so first up, one of the things like descriptive versus inferential statistics. So it's kind of in the name, it's kind of obvious. So descriptive statistics is about describing and summarizing data, using graphs, charts, and pretty much most of what we've been doing so far is descriptive. And inferential would be about drawing conclusions, like testing a hypothesis and seeing if it matches, and basically drawing, making inferences.
Yeah,
Yeah, it's in there. And here are some experimental variables that we went over. So independent is the one you're changing, and dependent is the one that you're measuring. Quasi-independent would be something that isn't randomly assigned. So it's usually something innate in your participants, like their age or religion. Usually that doesn't change within the experiment. Okay, and here are some other variable types that we went over too. So continuous would be something that is on a continuum or spectrum. So something like money or height, time would be something that's continuous. And discrete is something that has whole numbers. So something that isn't in fractions like continuous. We also went over qualitative, which is more descriptive, like adjectives and words, while quantitative is based on numbers. Yeah, and we also seen scales of measurement. So the first two, it is more on qualitative, and the last two are like more quantitative measurements. So nominal is just like a classification, or like kind of more like a name, like, or identity. Ordinal, I remember this by just going over like the rank or order of things, or a rating. Yeah.
Actually, ordinal, if you think about it, could technically be qualitative or quantitative, depending on where you're
yeah.
assigning it. If
Yeah.
you're like, how was your experience? You rented a car, was it awesome or was it crummy? Qualitative. If they're like 1 to 10, ordinal. So it really, that's a great point, John. These are really, it transitions from basically like qualitative into quantitative, or qualitative than it's purely quantitative. Yeah.
Interval is kind of similar to ordinal, but they're like equal units. Like it's like an interval, like equal units, and there's no true zero, while ratio does have a absolute zero. Let's see. Next, we did different frequency distributions. So a simple frequency distribution is just like the count, and it can be grouped or ungrouped. So if it's grouped, it means like you're kind of bunching up an interval, like a couple into an interval. And if it's ungrouped, it's just like on its own. Each like one is on its own. So grouped is usually will be represented by a histogram, while ungrouped is usually represented by a bar graph. You can also have it cumulative, so that's just like adding the frequencies across a series of intervals. And a relative frequency is you're just taking it and like taking each frequency and like dividing it by the total, so it's like a percentage. So if it's just relative, then it'll just be all of them will add up to 1. But if it's like a relative percentage, then it'll just be like a percentage. So you just multiply everything by 100. Let's see. Cumulative relative is just like taking each relative frequency and adding them up or down, depending on which direction. And yeah, and here I just like went over like, you can do bottom up, which starts from the lowest and then you add up, or you could do top down, starting from the top. Percentile rank ranking. So a percentile point is just like the value of a score. Yeah, the value score of everything like below that specific score. And yeah, kind of going along with the rank is like it's the percentage of scores that where all the values are below it. And you can also have a critical interval, which is just a specific score that's we think is important. And here are a couple of graphs too. So a frequency polygon would be like this line. You can see here, it just like takes the midpoint of each grouped interval. And these bars would be a histogram. So this is kind of like two graphs in one. And then, I don't know how to say it, like OGIF. Okay. Yeah, that's just like a special type of frequency polygon, but it's like cumulative. So it's like a specific type. So measurements of central tendencies. We got mean, median, and mode. And I know we went over like specific like which central tendency would be best for each for different scenarios. So for mode, you would want it usually in categories or like nominal situations, while median is better for preferences, ranks, and like when something is ordered. And mean is I think it was ratio, I think. Or I don't know. Okay, yeah. And usually like when you have a mean, you don't want like any outliers, or else that would kind of
It'll skew it.
Yes,
And that's
skew
when the median becomes more accurate measure of
Yeah.
central tendency. With
Mhm.
the outliers, and it depends on how big your outliers are. They're real close to everything else, it's
Yeah.
fine. Where they're like way out there, like 100,000 a year, $1 million a year versus like making 40,000,
Yeah.
it's gonna mess it up.
Yeah, it just kind of relates to the next slide I have, which shows skew. So you can see in a normal distribution, like everything is lined up in the middle. But when you have skew, the mean is a lot more biased in whatever direction, while the median mode are closer to the actual like center. And you can have different modal distributions, so like 1, 2, and 3 plus. This just counts the number of like humps you have in your graph.
Sure, your modes.
Yeah. And if you have like something non-modal or rectangular, it would just be like flat. Pretty straightforward. So then you have variability, which is just like measurements of how far, like how much your data is spread across, basically. So range is pretty simple. It's just your highest value minus your lowest value. Entire quartile range is the third quartile minus the first quartile. And interquartile range is just IQR divided by 2. And variance and standard deviation are related to the mean. So in the next slide, you can see how we calculate variance. This is population variance and this is sample variance. So it's the sum of the squares divided by the total amount in your population for your population variance. While in your sample variance, you divide the sum of the squares by degrees of freedom, which is n-1. And this will give you like an unbiased estimator for the variance. And lastly, we have standard deviation, which is just the square root of the variance. It's pretty straightforward. Yeah.
Everybody, hopefully you're feeling better about chapters 1 through 4 from that. The next stuff on our agenda would be, and we'll take a break in a moment, would be, we should have time for both, by the way. Finishing up assignment 3 and 4, so like walking through how to do that, and or probability. And we can go in order or out of order. I can certainly go with like what you all want to do the most, but nothing's going to be due until we go through both of those. we still have 2 hours, so realistically, we should get through both those. If you're like, I really want to practice probability first, we can do that. Or we can do assignments 3 and 4. It looks like assignments 3 and 4 are probably gonna be the most helpful. So we'll walk through that kind of step by step. I'll pull up my guide here, and then I'll walk you through that. So take, what do you guys need? 5, 10? What do you need to like, sort of like 7? Split the difference, say 11:25. Let it kind of sink in, digest, etc. Bio break if you need it, and we'll come back in about 7 minutes or so. And if anybody wants to talk to me one-on-one, let me know, but I might take a break also. So nice job, everybody. You guys are crushing it. Nice. Oh, wait. Ready, about ready to jump back in? So I have this now. This is not graded. This has to do with building a community. If you go to student resources and you click on chapter 4, you click on exam 1 reviews, you click on create thread and attach a file, you can all share the notes with each other that you just submitted. It's not worth points, but I would highly recommend it because you could benefit from each other's notes. So you just literally add thread, you would just put like my exam review, maybe some words here, maybe your name, browse local files, and you can just literally just grab the file. So it's under week 4. So you just go student resources, go into week 4, and then it says exam 1 reviews, is like a discussion board. And you just put like your name, here is my exam review I presented in class. And then now we have more notes for all of you to be even more successful if you care to share yours. Like it's not worth points, so I can't like say you have to submit it, but I think in terms of the community we're building, I think it'd be helpful because then you could all benefit from the way you broke stuff down. So. And then we'll go into, does everyone see that okay? And there we go. Kate already, yeah, submitted hers perfect. So I want to take a moment or two to do that while I pull up assignments 3 and 4. That would be fine. Perfect. And security. So hopefully you've all submitted your stuff in the discussion boards, or you felt comfortable enough to, like I said, it's so you can all benefit. I think we left off here. Is that about right? Did we get all the way to the top? I think that was where we were. So the next thing we do is let's go like this. Okay, so the next thing we're doing is the midpoint. So we're looking for the midpoint between these, because these are real limits. So the midpoint, remember, is exactly halfway through. Does everyone remember the midpoint calculation? Take, you said the two numbers you divided by 2. So let's take this right here and divide by 2. So equals 199.5 or no, 249.5 minus 199.5 divided by 2. No, we gotta do parentheses. The parentheses aren't working. Should be like divided by 2. So, and then what we're gonna want to do is we're gonna want to add it to the smallest value for the midpoint, 9.5. Because it's exactly halfway through 199.5. So you want to divide it by 2. It's the midpoint. So we're going between the lowest and the highest and getting the very middle. So we're taking and we're dividing it. Or you could also take, it also work if you take the smallest value and you add half of the range to it. That would work also. Because we're doing the midpoint. So it's divided by 2, but then we have to add it to the bottom value because we're trying to see where that range is between the values for the midpoint. So the midpoint between the two values, does that make sense? Because some of you, I think, are kind of looking at me like with the glazed over eyes. So I want to make sure I'm explaining that right. So this is going to be 22.5. Now, why is that 22.5? Well, if we think of it like a ruler, like right here, if this right here is 199.5 and this is 249.5, we're going to the exact middle between them. So our midpoint's here, and we know that it's half of our range is 25, but we can't just have sort of this number in the air. We have to add it back to this number so that it represents the distance to the midpoint from the starting point. And I can make that bigger because I feel like that's like kind of small. Is that better? So that you're not squinting everybody, Alona, anybody else? So does that make sense for the midpoint for like the first number? Right? So what would that one be? And how might we get there? 274.5. So we can go equals. You could do the range and divide it by 2. Or you do the formula. So I think the formula probably be the easiest. So we're going to take equals, put some brackets in there, 249.5. No, 299.5. 299.5, highest minus lowest, minus 249.5 divided by 2 plus F15. Nope, plus G15. Oh, that didn't work. I think I forgot something in our parentheses. Plus 199 plus, it's plus 224.5, 224.5. Now what? Oh, it's parentheses. It's got to be parentheses. It's got to be like extra parentheses because that is not making sense. Yeah. But if you notice, if we add the range, because they're all the same range, it would still work also. So this would be, I think I have a formula. Let me see a formula. Oh, yeah, that's why. That's why. So it's equals 299 equals 299.5 minus 249.5 divided by 2. We could probably do like, yeah, I know. Divided by 2 plus the bottom of the range to 49.5. Does that make sense? You see the formula now? So we're going to take the two values. Yeah. Yeah. So we're going to take the lowest minus the largest minus the smallest, or highest minus the lowest. We're going to divide that by 2. You probably want some double parentheses here. Okay, either way. And then we're going to add it to the bottom value of the range. But you might see a pattern here in terms of a simpler way to do it, because our range and our real values are all pretty similar with our apparent limits. So this absolutely works. Lowest number in our range, this is in the range, minus the smallest number, divided by 2, and then you add it to the bottom value of the range. But since these are all the same range, you could also, and I can write this down also just so you can sort of visually see it, you could take a shortcut. You could say equals the smallest, you could say equals the, try to walk you guys through that correctly. Or you could say equals, and we could take the range D13 plus 299.5, the real. Is that right? 340, 324. 299. No, it's not. It just goes up by 50. 299.5 minus. Yeah, so you add to the original one, so that's not right. So you add it to the original one, so as it goes up to 249.5, right? Yeah, 299. No, 3. It should be 324. Equals, it should be 324.5. So that would be, so we can go equals, and we take the 349. So it made with double brackets, 349.5 minus 299.5 divided by 2. There's our other bracket, plus 274.5. And that's our, no, that's not right. Why is it not? No, 299.5. That's right. Bottom of the range, 299.5. Yeah, 299.5, 324.5. So if we follow here, we're taking the largest minus smallest divided by 2 plus the bottom value of the range that you're looking at to your left. So what would our next one be if we do that? equals 399.5 minus 349.5 divided by 2 plus 324.5. I might have too many parentheses.
You need to add a parenthesis
Where?
right there.
Right there? Oh,
Oh, I can't tell what is red and black.
I just need to go like this. And like that. And that should work. Come on.
Give me one more. You said before, to close the two.
Oh, right. Is that right?
No,
No.
one more in front of 399.
Oh, yeah, there we go. Yeah.
And I have too much of the bottom.
Is it this one?
Yeah.
Yeah, there we go. So 349.5. So we're talking about the midpoint, like 374. Nope, that's not right. 374 plus.
Oh, you just said you added 320, and it's supposed to be added 345.
Oh, yeah, the range 349.5. Yeah. Yeah, there we go. Yeah. So you could literally now what you're going to see is you're going to start to see like a pattern emerge. So we know these are all the same limits, real limits, apparent limits, and they keep going up by 50. So we can use the formula. You want to use the formula to understand it, which is going to be your lowest minus the largest minus the smallest, highest minus lowest. However you want to think of that conceptually, divide it by 2 and add to the bottom of the range. Or as you can see, they're all the same. You could also go over here and say equals G12 plus 50. And you get the same answer. So because the midpoint keeps going up by exactly 50. Now, why does the midpoint go up by 50? Well, because they're all the range of 50 between them. So this is our real range, not our range. Like +1 is because they're all the same, the midpoint is going up by that. But it's really largest minus smallest divided by 2 plus the bottom of that new range. So like for this one, it's going to be 499.5 minus 449.5 divided by 2 plus the 449.5, and it'll be exactly 50 points higher. Because we're going to add it to the bottom of the range. So largest minus smallest divided by 2, like I have right here, largest minus smallest or highest minus lowest, whatever's the easiest to remember, divided by 2 plus the bottom value of the range. And that'll go up by 50, which is your real range, because it's literally that midpoint. You can add the 50, but you want to understand what you're doing because we're doing the midpoint. Does that make sense? Because the reason we can add 50 is we see the pattern. Valentine, yeah. Oh, it's either. So this is the largest minus the smallest, or it's the highest minus the lowest. They're the same formula. It's however you want to do it. So if you're like larger and smaller makes sense to me, or higher and lower makes sense to me, whatever's easy to think about it. So this would be the same thing. So we can either add 50 because it happens to be going the same, or rely on that formula. But the formula is like the background behind what you're doing. So does anyone know what this one will be? We're going to take 499.5 minus 449.5 divided by 2 and then add to the bottom of that. So you should have 474.5. The shortcut would be to add just the real range to it because of how they're all the same throughout, and we can see the pattern emerging. But you want to understand this to get there, not just adding the real range. Ilona.
What if they don't all have the same real range? You still
if you had the column like that and they were different, it would still, that's just still work, yeah. But I would probably rely on this formula so you're not getting it wrong. So this one would be 474.5. Everybody knows how we got there, yeah.
We first started to get 2.4.5. What value did we have?
So we did 249.5 minus 199.5, largest or highest to smallest, divided that by 2, and then we added that back to the 199.5, which is actually the real range. By half, because it's a midpoint. So what we're doing is, so these all, the midpoint happens to be 25 between all these numbers. Because the real range is 50, so the midpoint is going to be 25. It's literally half. Because remember, we're talking about like the midpoint, very similar to the median, kind of like the same thing, but we're talking about the midpoint. So if we have all these numbers, where do they sort of like, where's the midpoint between them? If we sort of like, we take two cars and we drive towards each other like playing chicken, where are they going to crash? That's your midpoint. Because they're going at like the same speed. As if that makes sense. That's another dark example like stuff, but let's hope nobody gets hurt, right? So does everyone know what we would do here? What would we do? We do 549.5 minus 499.5 divided by 2. So our midpoint is now, our midpoint is now, so there's the real range 50, half of that's 25. And if we add that to the smallest value in that range, we get our next midpoint, which would be 522.5. Does that make sense? Or we can do it, so if I go equals, and I'm going to say 549 549.5 minus 499.5 divided by 2 plus the start of our range, or our real range, really 499.5. Should, oh, I didn't do that right. I gotta add that differently. Yeah, go ahead. I got like parentheses issues. Go ahead. Yeah, question, Gustavo? So this is 524.5, because why does it go up like that? Because we're looking at the midpoint between each range. So the midpoint is 50 because it's half. So if we're saying we have this range right here and it's 50, midpoint, this is that real range, okay? Midpoint is always equal to half of the real range plus the bottom of the real range. Not the range, the bottom of the real range, that 0.5. So you can think about it two different ways, but the best way is to take your range, largest minus smallest, divide by 2, add to the bottom value of the range, which accounts for it being one more by doing that. Does this make sense? So what would the next, so 524, the next one would be 574.5. Does that make sense? Now, if you want to think about that, if we have literally on our scale here, what do we have? We have 550, that's 550 to 599. 550 to 599, right? So that means it's going to be 549.5 to 599.5. I think I'm copying that right. And then I'm going to take this car and this car, I'm going to drive them towards each other at the exact same speed. They're going to meet smack dab in the middle. That's our midpoint. Make sense, everybody? So the next one would be 624.5. So largest minus smallest divided by 2, add to that bottom value. Our next one is 674.5. Make sense? Is that clicking so far? Largest minus smallest, divide by 2. You're adding your midpoint to your bottom of your real range. That equals the midpoint between the real range. It happens to be 25 throughout. Are we having sidebars on stats back there or something else? 724.5, does that make sense? And then our last one would be 774.5. Does all this make sense so far before we do anything else? So the apparent limits, we talk about the frequency. There was something happening 4 times between 200 and 249. There was something happening 45 times between this or this. Now, we're not saying necessarily where these people scored. We're just saying in this range, the frequency of the score happened X number of times in this range. So our next thing is, does everyone have that, the formula, the whiteboard making sense? Okay. So our next thing that we would look at would be our frequency times the midpoint. Okay. So let's go like this. Let's go unhide and let's go like this. Hide. So the frequency times the midpoint. So we literally have that information in front of us. Let's make this a little bit bigger. Frequency times, come on. Frequency times the midpoint. So we're going to say equals frequency E15 times the midpoint G15. We're doing the frequency times the midpoint.
What's the multiplication?
It's the star key. So if I go like that, we should have 898. So the same, so we're going to take our frequency right here. So we're going to say equals E14. So we're going to grab that number, shift 8 key times the midpoint. So frequency times the midpoint, which is G14. So you're multiplying frequency times midpoint to get the frequency times the midpoint. So our next one would be 2196. So equals G13 equals, no, F13 equals F13. All I'm doing is I'm just referencing the letter and the number. I could put 31 in there, it would still work. I'm just saying, grab this out of the cell to Excel times the midpoint, which happens to be G13. No, I did that wrong, not F13. That was E, that was E13 times G13. Frequency times the midpoint. And we're going to end up with some pretty big numbers here. 660. Yep, that's right. Equals E12 times the midpoint G12. And the blue and the red again are what we're multiplying. I'm just telling Excel go find this number. Then I go like that. Same thing here. Equals E11 right there times G12. Nope, times G11. Does that make sense? Frequency times midpoint. Frequency times midpoint.
The fourth one, I have 2,400.
Make sure that I have that right.
Oh, I did that one on accident.
If you so be careful. Make sure you're doing the exact letter and number, or do that. So same thing, this is equal to E10 times G10. And then you can see why. Frequency times midpoint. Part of this exercise is also that you're familiar, that you're okay with working with large numbers, okay? Equals E9 times G9. Did I do that right? Z9 times G9. Frequency times midpoint. That makes sense. Yep. Equals G, equals E8 times G8. Multiply those numbers, frequency times midpoint to get the column in the table, frequency times midpoint. Like that. Same here equals E7 times G7. Look that up for a second so you can see what I'm multiplying. Frequency times midpoint. There we go. Equals E6 times G6. Is that right? Frequency times midpoint. Yeah, that makes sense. Those answers are correct. Same thing here. Equals E5 times G5. That makes sense. Frequency times midpoint. And then equals G4 equals E4. E4 times G4. That should be your frequency times midpoint column. You're just taking frequency times midpoint we already came up with. I will wait till everybody has that. Maybe give me like a pulse temperature check, like you're that far and it's making sense. And then the next thing we'll do is we'll do midpoint squared. I think we might ask for it on the exam. I think that's on the exam. What was that? You probably won't use frequency times midpoint. We're probably gonna use like more like the percentages in terms of like the application. Like you said, part of this is just like, if we were to ask you and to get a sense of work with the larger numbers. So, but yeah, that's rarely. I mean, you could maybe, if you're talking about a certain type of behavior, how often does it happen? Including the midpoint, but generally it's gonna be like more your percentages. It's gonna be more of this stuff and that, and this, and more of this is more just like understanding like the multiplication. Also, some of you I waived math requirements, somebody did not. Some of this is like algebra stuff too, that might be a little bit of a review. So our next thing is everyone have up to this point, and it makes sense, I hope. If not, tell me we can go back. We're gonna do midpoint squared. So I'm gonna hide all of this. And this is hide. Midpoint squared. And we're gonna delete that. Yeah. Delete that. So midpoint squared, we're gonna reference our midpoint. So equals G15 to the second power. And we should get that number. Equals F12, no, equals F14, nope, equals G14, midpoint to the second power. Midpoint squared. So we're multiplying it times itself. Now you could take, and you could say you could say 274.5 times 274.5. That would still be squaring it. Whenever you square something, you're multiplying it by itself. So same thing here, we're gonna say equals G13 to the second power. And we're gonna get that number. Equals G12 shift 6 to the second power. That number. Equals G11, that number, midpoint to the second power. That absolutely makes sense. That is absolutely, did I get that right? I think I did that right. G11, second power. That should be right. Yeah, G11 to the second power. Midpoint oh, yeah, that's right. Okay, that's right. Yep, okay, perfect. Equals G10 to the second power. That number equals G9 to the second power equals G8 to the second power equals G7 to the second power. So we're just squaring the midpoint. Equals G6 to the second power equals G5 to the second power and equals G4 to the second power. So now you have your midpoint squared. Does that make sense, everybody? How we out there? So the next thing that the assignment asks us to do is the frequency times the midpoint squared. So let's go like this and unhide. So let's go like that. Let's make that bigger. Let's make all of these disappear. Unhide, hide. Right, just midpoint squared. Okay, so let's make all of these disappear. Hide. Okay, frequency times midpoint squared. So equals frequency, which we have, which is E15 times midpoint squared, I15. Frequency times midpoint squared.
Oh, we're not doing, okay, I got.
Be careful because there's a lot of columns, a lot of numbers. Frequency times midpoint squared.
So we're not doing.
So technically, you should be able to go like this. You should be able to go frequency times midpoint. You should be able, this should also work. We say equals H 15 to the second power, right? That should work. And it does. So you can either, so there's two ways you can do this. We have frequency times midpoint. We're just squaring it. So you can either take all these values and square them, or you can take the frequency times the midpoint squared. You get the same answer either way. So we have the frequency times the midpoint. We're just squaring it. So we can either take all these values. I'll do it more than one way. So the first thing we did with this formula right here is we did frequency times midpoint squared. So we already have frequency times midpoint. We're just literally squaring that column. But if we wanted to, we could also take, so remember, so let's write that number down. 80604. But we could also, if we wanted, we can do it either way. We could say the frequency, which is equals E15 times the midpoint squared, which is I15. Does that work? No, I don't think it, I think it's that E15 times, I know that doesn't work. Yeah, just square the values because it messes it up in Excel. So we're literally just going to square it. We're just going to say this one is going to be squared. So frequency times midpoint squared. So equals H15 to the second power. We're just going to square all of our values. We could literally take this and hide it so you can see it. So we're just going to square these like to the second power. So this is equal to this number, H14 right there, to the second power. Yep. This is equal to H13 to the second power. This is equal to H12 to the second power, equals H11 to the second power, equals H10 to the second power, equals H9 to the second power, equals H8 to the second power, equals H7 to the second power equals H6 to the second power equals H5 to the second power equals H4 to the second power.
Yeah, I didn't do it. I thought at first we talked about E
Yeah,
times G squared.
no, we're just gonna square it. It's simpler, it's less steps, and we don't run the risk of accidentally calculating something wrong. So we're just gonna square that. So that's all we've done so far. So we've done all of these, and then the next one it asked us for, I think, is percentage. Okay, so. I'll hide that. I'll delete these. You can copy them if you want, but I'm gonna walk you through how to get there. The percentage of the cumulative frequency to all of the frequencies. So we're 4, so our total number of frequencies is 371 times something happens. We're gonna take each of our values all the way up to the top here, and what we're gonna talk about is so that should be equals F15 divided by F4. Yeah. I'm getting the decimal for the percentage. So the first frequency against that. So 4, like it's a proportion, 4 goes into 371. So our total is 371. We're going to work through the percentage, the percentages.
4 divided by 6.
4 divided by 371.
So that's 12 divided by- okay.
Yep. Equals 12 divided by 371. No, hang on. That's not right.
Would it be
No, it'd be 8. It'd be 8. We want to do this one. So we're doing this column, the frequency into all of it. So we're not doing it cumulatively yet. We're just doing of this list. Our total, remember our total is 371. So we're going to take each one of these and divide it into 371, and that's going to give us our percentage over here. So I'm going to take equals E14 divided by 371. Remember, it's a proportion. The total number of times the thing happened was 371 times. So we're taking each one of the values for each column for the frequency and dividing it into our total, which we could say this or that. I'm doing that because it's easier for you to see it visually. And these are just the decimal version of the percentage. Remember, if we multiply it by 100, we're gonna have our percentage. So like this would be 1.07%, for example. Let's do it. We'll do a column with percentages and rounded percentages to be clear on it. So this is going to be equal to E13, 19 divided by 371. And you're going to have 0.05. So we're doing the decimal version of the percentage. We'll do the percentage version in a moment, okay? So let's just, I'll relabel this. This is percentage in decimals. Okay. I'll show you what, we'll do it, we'll do another column here, just so it makes sense to everybody on how to convert those in a moment, okay? So it's the same thing. This is gonna be equal to E12, which is 36 divided by 371. So we're gonna divide each one of the frequencies into the overall total frequency. Same thing. This is E11 divided by 371. This is same thing. This would be E9 divided by 3. I'll just do it. Equals E9 divided by 371. Yep. This is equal to E8 divided by 371. Our percentages are proportional to the same thing. We're just doing percentages in decimals at this point. This is equal to E7 minus 371. I'll put this on Zoom. So I'm not sharing it. So our next one, so we're right here, if you're following along on Zoom, would be, this would be equals E6, so you can see what I'm dividing, divided by 371. 0.7078. This is going to be equals E5 divided by 371. 0.27, and this is going to be equals to E4 divided by 371. Percentage decimals. Does everyone get that? Does that make sense so far? Let's do percentage. And let's do percentage. Let's do percentage without decimals. And let's go search. Okay, percentage without decimals equals this column, K15 times 100. That's your percentage. Because we're moving the decimal place over 2, so you can literally just take any of these and see, it's going to move it over. So we're multiplying it by 100, and that's telling us our percentage. Now that is our, I'm not dealing with rounding right now. We'll talk about how to round percentages in a moment. We're just talking about like what the percentage would be. So if I write, so we either have the decimal 0.05, or we can have 125%. Or 5.12%. That's what we're looking at. We're just multiplying this column by 100. So equals, what is that, K12 times 100. 9.73%, or 0.0973. Want to talk about the decimal. So if we do the same thing, multiply the next one by 100, we would get 12.12. That makes sense because it's going to places to the right. Same thing here, Phil. 15.63. So when converting, a decimal percentage to a percentage, multiply by 100. Why? Because we're still talking about 0 and 1. So proportion is always 0 to 1. A percentage is always 0 to 100. This is your proportion or frequency, depending on how you look at it. Or you have a percentage, which is going to be 0 to 100. So we just have to multiply it by 100 to get there. So we're going to go like that up. This one up. Take that one, fill up. This one, fill up. Now you can do fill up as long as you understand what you're looking at, okay? I'm just doing fill up because I think a lot of you have been doing the math at your desk here, just to like save time and you give you a chance to check your answers. Fill up. And this was percentage, just regular percentage, not with decimals. Does that kind of make sense? Like one sort of like the decimal way of looking at it. They both have decimals, I'm aware of that, but I'm just saying like, are we talking about like more of a proportion or a frequency 0 to 1? Or the number of times something's happening in relationship to everything else? Or are we talking about like more of like a percentage with multiplying it by 100 where you're gonna go over 2 decimal places? And then we have rounded percent. But let's delete these. Let's hide the other ones. Hide. So rounded percent. So does anyone know the rule for rounding? So if you have 5 or above for rounding, you go up, and 4 or below, you round down. So now we want to round the percentage. We want to get rid of these decimals. So 1.07, we would take 1.07. We're usually gonna go 2. We can go one or 2, or we can just make it into a percentage without the decimals at all. So if we say, I mean, you can go through all of these if you wanted to. You can go backwards. This is going to tell me this should be a 2. This tells me that the 1, 2, we're going down to 1. The 1 tells me that we're going to, so we're going to stay at 1. 7, we do a 6, 8. That'd be a 7. That'd be a 2. That would be a 9. That'd be 1.08. 1.1 or 1%. Did that make sense, or did I completely like lose you? So you can, or we can literally just go like, you can also go into Excel and you can just go like, just for like convenience sake, you can go like this. We'll do it. Come on, let's see if we'll do it. You can just take off those percentages. Now it's a lot easier to round. Now it's real straightforward. You see what I did? I just got rid of these decimals. We can go back. It's right here. It's under number. Like these could go on and on and on and on. Now you can't see them because there's not enough space. We went through what? Through 7-1. This should be like. So the easiest way to do it would be to go to like the 10th or the 100th place. So we can all agree that we have 1.078. That's to the thousands place, right? So the 8 means that we should round up, which means the 7 becomes an 8. So now we have 1.08. I just rounded. So then if I want to keep rounding and get like to an integer or a whole number, we look at this. So this tells us we should round up. So now we get 1.1. And then this 1, remember when I said 4 or below, this tells us to round down. So our percentage is 1% for rounding. So we would just go, you could take, so this is going to be 1%. See, this is not, I got to change the format. I don't want percent number, general. So that's 1%. So 2.15, right? Or 2.156, like maybe just for sake of making it easy, let's make them to the thousands place. So maybe one more. We gotta do one more for that to work. Let's make it to the, nope. So 2.156, right? 2.156. Tenths, hundredths, thousands. 6 as we round up. So we get rid of this. This is now 2.16. The 6 right here says round up. So you do that to the next number. So this is 2.2 because we rounded up. The 2 below 4 below says round down 2%. Now you could go all the way out from the amount of numbers you have and work towards it. It would still work if you do those steps. I'm just trying to simplify the process. So this would be 2%. Make sense? Does anyone have a guess what this one would be? What percentage would 5.13 be? 5, yeah. 9.7, 10, nailed it, yes. That would be 10%. This would be 5. This would be not 0.5, this would be 5. 12.129. 12, that's right. 15.63. That's right, 16. Yep. Because that tells you 5 or higher, go up, 4 below, go down. You can start with the 10th place, and that would be fine. 18.598. 19%, yeah. 9.434. What? Yeah, 9. Making sense, everybody? 8.625. That's 9, yep. 7.817. 8 or 7.8, it would still work. 7.27, 7, yeah. 2.42, 2. So that's your rounded percentage. Make sense, rounding? Pretty straightforward. Then the next thing I think we're doing is the cumulative percent. Yeah, so the next thing we're gonna do is we're gonna do cumulative percent. Unhide. And we'll hide this. Yeah, absolutely.
By itself, how would we go any further? Like scroll the bar. Yeah, the bar. Oh, wait.
It should let you scroll. I might have to call the IT guy down here and tell him to get it together. Because Excel should basically be unlimited columns and rows. So if anything, it would be glitchy. So cumulative, right? Cumulative is the accumulate. We're gonna accumulate percentages. So this is gonna be 1, because that's the first column. This is gonna be 3, yeah. So this is gonna be equals E14, no, N14 plus M15, no, plus M13. 8. 18. Does that make sense? So we're taking these percentages and we're adding them to each other. So for example, so is that one right? Yeah, let's do like that. So 1 plus 2% is 3%. 3% plus 5% is 8% for the cumulative percentage. So the next one would be what? 18. Yeah. The next one would be 30, right? The next one would be 46. Yeah, whoever said 46. The next one would be 65. Yeah. The next one would be Phil up 74. The next one would be 83. The next one would be 91, 98. And then we should have 100% because it's cumulative, right? But that did the math weird. This would be 100 though, for sure. So you should have cumulative percentage should look like that. Make sense? Everyone have that so far before we do any other columns? I'll wait till everybody has that before I show you the next thing. Maybe tell me as you, or give me a nod or something, so I know that everybody's up to that point. Makes sense? Okay, cool. Cumulative rounded percentage. And let's delete these. So cumulative rounded percentage is about the same. 1, 3, no, 1, yeah, 3, 8, 18, 30. So God, I can't explain that. That doesn't, no, I need to explain that again because I explained it wrong. So this is going to be your let's say cumulative percentage. So cumulative percentage is going to be each one of these, but we're not going to round because it's cumulative. We're not rounding. I show you how to round. So there's cumulative percentage, we go up towards 100, and there's cumulative rounded percentage, and they're handled slightly differently. So your cumulative percentage is going to be L15. I mean, like that's literally, so it'd be L15 times 100, technically, times 100 times. No, it's not right. No, we don't have to multiply it because we already did that, remember? So this is L15, this is your percentage, and then your cumulative would be M15 plus L14, like that. And we would just continue to not round, we're just accumulating the percentages. Make sense? So I'm adding this number to get that number. I'm adding this number to that number, sorry, this number to that number to get this number. I'm adding my percentages to each other. So if I have 18 and 12, it's not going to be this nice clean rounded percentage of 30%. It's going to be slightly different because I'm adding the actual decimals all the way. That was the cumulative rounded percentage that went all the way up to 100. So there's rounded percentage, just what each percentage is with rounding, and there's cumulative rounded percentage, which is as they accumulate with the rounding, and then there's just cumulative percentage, which is I'm literally just saying add the running percentage to the next percentage without doing any rounding. That's the only difference we're doing here. I'm not rounding anything for my cumulative percentage. I'm just adding 45.822 plus 15.633 is 64.20. I'm just accumulating all my decimals, accumulating the percentages. 64.420 plus 9.434 will be the next one, and then we'll have another decimal. 73.420. Same thing. So we're gonna go like this, fill up. Like this, fill up. Like this. Fill up. Oh, is that right? Yeah, I did that right. Yeah, that's right. Same thing. Fill up. And fill up. And then you get the cumulative percentage. Now, something is going to happen in a moment if we look at cumulative rounded percentage. We're going to have a problem as we get close to 100 because of the rounding. And I'm going to show you how we handle that rounding issue. So this all makes sense because it's all the decimals and they collectively equal 100% by adding them to each other from 1.078% all the way up to 100%. That should make sense for everybody, right? Make sense so far? Have I lost you all? Okay, I've lost you or it makes sense.
No, can you just like show how to?
So I'm going to take this number right here. So I'm doing cumulative percentage. So on the very bottom one, there's nothing to accumulate. Then I'm going to take 1.078 times 2.156. I'm going to get 3.235. So I'm adding this percentage to that one and I'm accumulating. So 1.078 plus is equal to that. This one plus that one is equal to that one. 8.356. So I'm just literally saying this. So this is 9.704. It's not 10. It's not rounded anymore. It ends up being 18.059 because we have some other numbers to the right of our decimal here. So then 18.059 plus 12.129, 30.189. 30.189 times 15.633, 45.822. Makes sense? This should be not. Why is that? Makes sense. It's not supposed to do it like that. That's not right. Does everyone, does cumulative percentage make sense, or should I walk through that a little bit more? We're adding, yeah, we just did, now we're going to, so cumulative rounded is done slightly differently. So we have our rounded percentages, but we're going to run into some problems here. So our first one is 1%. That makes sense. Our next one is 3%. That makes sense. Our next one is 8%. That makes sense. Our next one is 18%, 30%, 46%, 55. Is that not right? 65%, right? We have 65, right? 65%. And then our next one's going to be, is that right? Yeah. No, because we're rounding. We want this problem to happen because we're going to address what happens when we approach 100. So you're right. Like if we are not rounding, it is totally 64%. But if we round it 65, because no, we did that wrong. 64. You're right. Right. 64 point. Yeah, 420. Cumulative round is 65. Yeah, so that'd be 65. No, that would be 46%. We're doing cumulative rounded percentage. So we're letting it accumulate towards 100. So 64. No, you're right. That's 64. 64, 73, 81, Oh, that's 82. That's 82. 90. So for this to work for me to show you, let's just assume for a moment that our rounded percentage was 3% at the top. I'm aware that it's not, but it has to do with what the rule is, so I can teach you guys the rule. For some reason, these numbers worked out really well, but if you're rounding up and down, they could work out not correct. So we cannot have that. We can't do that. That doesn't make any sense. So on the last one, when you're doing cumulative rounded percentage, you actually would round down so that the math works, kind of like the Band-Aid. So on your if you're rounding your percentages and you're like, I'm going to hit over 100, you take your last value and you round it so that it makes sense, so that you get to 100% when you do with cumulative rounded percentage. So always follow that rule. The 5 or above, round up, 4 or below, round down. But if you're rounding up and down throughout your whole cycle, you might start to get to like 102, 103% doesn't make sense. So the very last cumulative percent, you actually round to get up to the 100 even, because it's the cumulative rounded percent and we cannot exceed 100. So what we're doing is we're accounting for the rounding error of rounding throughout. And when I say error, because rounding is going, you're changing the number slightly. So if we change it, we round up a bunch of them. This might not be cumulative. So that very last value, we're going to make sense of it so the cumulative makes sense. So we would take this 3%, we would round it down to 2%, so we would get to 100. Does that make sense? Like it's that last value, so the acclimation of them makes sense if you're rounding up and down. That's how you deal with getting rid of all those decimal points at the very end. Some of you are glazing over, some of you that's clicking. The rule is round, so rounding makes sense. Cumulative makes sense, right? We're gonna accumulate, we're gonna get towards 100. Rounded cumulative percent still makes sense, but that very last value rounded accordingly so that you get to 100, not some number north of 100, because you can't have more than 100%. I can't have more than all of you show up. It's not mathematically possible. That's how we deal with it. We round that last value so that it makes sense, because it's cumulative rounded percentage. So that's when we round it slightly differently. We would round up or down on the last value depending on what we need to get to the 100%. Make sense? Yeah. So we have cumulative percent, and then these just happen to work pretty well. This should actually be 98. And then we have cumulative rounded percentage. So the only difference is, for the sake of argument, if this was 99, we'd have to make this last percentage like 1 to get to 100%.
So what's the difference between column O and the column M?
I think we did it twice. Yeah, so yeah, we did it twice. So rounded percentage, I can delete that. Yeah, we did it twice. I think I got carried away because I just wanted to make sure that made sense to everybody. So cumulative percentage, all your percentages up to 100. Rounded percentage, deal with the stuff with the decimal. We're gonna go typically a 10th or 100th, or like in fact the integer. We're not really gonna go 1,000. We're not gonna go several decimal places over. And then cumulative rounded percentage when it doesn't work. Now it can work real nice. In fact, in our example, it absolutely works fine. There would be no reason to round in our example. But if you were dealing with, if you had, let's just say, for the sake of argument, we have cumulative rounded percent. So let's just say, for the sake of argument, we have 22.2. These are like our regular percentages over here. Percentages. And it's 22.2. Let's say we had 30.5. We had 61.9. We had 75.6. We had 80.5. 9 and we had 99.9. That ought to work. Okay, so we're gonna move this over here. That's gonna be 22%. This is gonna be 31%. This is gonna be 62%. I'm just rounding cumulative. 62%, there's gonna be 76%. There's gonna be 81%. And we need like some, we need some values for this to make sense. So let's say our next value to get up here was 20. Right? So we end up with 100.9%. We have to round that down to 100%. Does that make sense if I break it down like that? Like if you're starting to exceed 100, you just take the last value and you make it work, like rip the Band-Aid off fast. Make sense? Are we in time? Okay, we're about 10 minutes out. Now, I think that is the first half of that assignment. What is the next part of that assignment? So we did that first part. So we did all that. Simple frequency distribution. Okay. So the next one are the examination grades for students, which I think you can cut and paste, copy, file, new. Really? I'm gonna find out right now. And if not, I'm gonna help you guys create it by hand. Oh. Can't copy and paste from a different computer, clearly. I'm spoiled because at home I have two computers that connect to each other. So in class activities. What's that? That's in right here. In class 7, 3, and 4. Enable editing. Let's see if it works. I'm not sure if it's going to work. But if I grab these, can I think if I go like this and then I do the other one, like the last one, I think it'll work. I hope. Let's find out. That might have worked. Ooh, that did work. Okay. So we're gonna make a table. I would create a new sheet, or you could keep working in the same one. It's either way. Whatever's easier for you. Blackboard will allow the submission of multiple files. And then I need to grab the last column, which was right here. So cut and paste like the whole square, and then cut and paste that last column like that. And then you don't have to type it by hand.
How did you paste it?
What?
How did you paste it?
I took and I highlighted all of these numbers, but not the last row, copy. And then I did the last row, and then it came in, I would say, pretty clean right here. Make your columns wider. So if you're not sure how to do that in Excel, put it between the, and then just make these bigger.
Did you just do insert? Because I'll have to paste option.
Control V should work. Control C, what? Yeah, absolutely. So we take these right here, and I did everything except the last row, because I feel like it's going to get wonky if I don't do the, so I took this right here, and then I pasted it by doing Control C, Control V, and I got all of these numbers to the 55. And then I went into Word again, and I grabbed these last ones that I forgot to grab. I did Control C, And then I went back into the Excel and I put the cursor here. I did Control V, and then it gave me those real nice. Looks like they're like a little like off-centered or something. That's probably, we could probably just take the whole thing and then just go like that. And now they're nice and pretty. Does everyone have that in Excel, or is it just not working?
Mine put everything into one cell, and not the whole thing.
You might have to type them out by hand. You guys want me to read them to you? Would that be helpful? I'll read the numbers to you and you just put them in Excel. Yeah, I'll read them and you can see them. So your first number should be 72. I'm gonna go to right to left or down. What's easier? Down. 72, 68. I'll go slow. 72, 68. Actually, you know what you might be able to do? Will that work? No, you can't do. Are you like the copy and pasting specialist here?
I guess so.
Do you want to tell them what you did in the back?
I did what you did. I just Control C it.
So it should be just Control C. Nobody come over there, guys? Because it should work. We can type it by hand, but that's so like 2005. Yeah. I mean, like, yeah, I don't think you should have to do that. You should really just move the numbers into Excel, and then we'll create a frequency distribution table.
51, 58, 65, 70, 74, 36.
Okay, so are you guys doing, or do I need to come around? Can you show them how to do it? Or it makes sense, or it's still there? You want me to go over there? Okay, you got it. Yeah, and then you just show me columns.
69,
And then you, I'll show you how to, show you
49,
what happened over.
89, 72, 81, D, 52,
There should be a,
53,
there should be a power button on your actual desk,
88,
or you got a loose connection.
39, 42.
You probably have a loose connection because it looks like, your computer CPU still on, or it just completely crashed out on you,
31,
which I know is not what you want to happen right now, but that's,
38, I'm sorry, 89, 75,
on the same Excel is fine.
57,
I'm just putting them on a different one, it's easy. If it's better for you guys, we just keep working on the same documents.
46, 92, 45, 58, 73, 94, 91, 66, 76, 65, 40.
That work? Yeah. That was- Oh, you did.
54.
Oh, it doesn't, as long as the data's there, it's fine. It doesn't matter if it looks, if it looks wonky. I mean. We're doing simple frequency distribution. Did you just like totally help everybody, which is awesome? Everybody have the data, or at least a good sense? And I'll probably make this our last thing. So like frequency distribution, if we looked at our other worksheet, which is right here, I believe. This, see how this is showing you frequency distribution with our limits. Now I'm asking you to tell me how many times that number comes up. You can count it, but that's so like 2003. It's so barbaric, right? So you can go into Excel and you can take all of this right here and highlight the entire thing, and you can go conditional formatting, new rule, format unique or duplicate values. What? Okay, so what you can do, a frequency distribution, we want to see how many times the thing comes up. So what you can do is you go conditional formatting, new rule, format only unique or duplicate values, format, fill, pick a color. Okay. Okay, let's do it again. Highlight the whole thing, conditional formatting, new rule, unique or duplicate values, format, pick a color. Okay. You should. Pick a conditional formatting, new rule. We're trying to create a table here. So our problem is how many times the number comes up. If it's in yellow, it comes up more than once. If it's in white, it only comes up one time. Yeah. And I think we might even be able to have it tell us with like a pivot table, so that we don't have to count by hand. But all I'm saying, don't let that freak you out, is a frequency table is literally this. How many times did the number come up? Okay. So one trick I can do with Excel is I can take take all my data and do, or you can just select that, or just highlight it. If you're in the same Excel, just highlight it so you don't reference the other table. You go conditional formatting, new rule, format cell, you say format cells that contain, not duplicate, this is actually better. Cells that contain cell value equal to 72. Because that's our first value. Click, say format, pick a color that you can see, say okay, say okay. That's your frequency distribution. 72, 4. See what I just did there? Do you see how easy it is to count them now? So that we don't have to do it by hand. So if I'm going to do a frequency distribution table, so we're going to say frequency distribution table, and we're going to have the value on, we're going to have value in one column, and we're going to have the frequency in the other column, literally that. So we're going to say 72 happens 4 times. Now, what about, and then what we can do is do conditional formatting, clear rules from the entire sheet, clear. You can take your same values again, and you can say, well, the next value is 68, but I don't want to count them because that's annoying. New rule, format only cells that contain cell value equal to 68. Pick a color, I like green. Okay. So this is going to be 68, 3. Frequency distribution table. A simple frequency distribution. I'm just saying, how many times does the number occur? So then you can just take, you don't even have to highlight, you just say clear rules from entire sheet. And then we got 81's our next one. So we just take all of our data. You can see that the third value is 81. And then you go conditional formatting, new rule, so only cells that contain equal to, what did I say, 81, that's the third value, 81, say okay. Nope, see, I didn't do that right because I need to pick a color. I can't see anything. New rule, only cells that contain equal to 81, format. I know we're running on time. I'm just showing you like a time or two, and then we'll resume this on Monday, and I won't make this due yet, but I will assign chapter 5. I want to assign chapter 6 yet. We didn't go over it. So we'll just do something for chapter 5, pre-test, post-test. Pre-test maybe on 6, nothing on post-test for chapter 6. You don't have to submit anything. I'll walk you through the steps and the SPSS in class. So if you want to create a simple frequency distribution table, you say, okay, that's 81. And it happened, looks like 4 times to me. And you just go through all your values till you get to the end. Does that make sense?
Yeah.
So then you just clear, yeah, go ahead.
I didn't push it back with this table, but the previous table we were doing, when you put like a percent next to the numbers, every time I would do it, it would make it like 1,000%, or like 10,000% or something. I want to do just like 100%, 98%.
So that's probably, it's either, it could be this, yeah. So there's a percentage and then, why did it do that? No, not accounting. It should be under general. Should be under your decimal places. I might have to look at it with you, but it should just be like a setting.
Yeah, I want that too. It would still give me like,
1,000.
yeah, like or like something, yeah, 1,000.
My guess is
It's just like
it's glitched out or your proportion on your math and your frequency isn't working. So what we'll do is we'll finish 3 and 4. Exam 1 is still due Wednesday by midnight. So a week from now. So we can still do a little bit more review, or you can ask me questions. If you're stuck on Monday and Wednesday, we can do more review. And then what we'll do is we'll do this, some review on proportions. So at this point, work on this on your own if you want, but we'll do it in class. And then, so it's not really due yet. It'll probably be due like Monday night. Well, you should at this point have done chapters pre-test 1 through 4 and post-test 1 through 4. I'm going to say do chapter 5 pre-test if you haven't already, and chapter 5 post-test we could say due by at this point Monday at midnight, so we have more time to practice chapter 5. So you don't have to do the post-test yet. And then WebAssign, I'll say due by Monday at midnight. So you can still bring questions to class. Now I can modify the deadlines if we get like stuck or you have a bunch of questions. I can extend that. We're still clipping along fine because we should be approximately here right now. And then we want to get through chapters somewhere between chapter 6, 7, or 8 by the end of next week, approximately. But there's built-in extra time because we still have about a week or 2 extra of instruction if we need it. So we're still clipping along just fine. Before you all run out, I know we're a few minutes over time. Questions, thoughts, concerns, I can totally post that. I can post the recording. What do you got for me? Anything not making sense? And or is it making sense? Maybe give me like a temperature check before you go, like pulse check, like is it more clear? Concerns? I posted that. Now I can post the answer key, but I want you guys to be able to know what you're looking at. Any other questions, thoughts, concerns, anybody? I can put that in there. I can do that like today.
Sure, whenever.
Yeah, and then I usually also email you guys too.
Right.
Yeah, I can do that. Yeah. See you guys later.
So we're gonna post it in the announcement, right?
I'm gonna post the announcements in the homework. Yeah, everything I just said, I'll post.
Have a good day.
Yeah, you too. Good professor voice, by the way. It's good. You're gonna be a research professor. You project well. That's good.
Yeah, it's I don't know. This stuff gets like speeches. I would say, well, I'm only saying this because my speech
Yeah.
teacher wanted to get me on the speech team, but
Yeah.
when it's like unprepared, I'm not as nervous. But when it's just like stuff like this, where it's like kind of just like winging it, kind of, especially with topics I don't know as well, I'm kind of like I get kind of like, ooh, I don't, yeah.
It takes practice. My very first course I taught was to a bunch of doctoral students who all had master's degrees, probably already taught before. And the first hour and a half was like incredibly nerve wracking. And which was super fun. And it's always gonna be a little over your head. There was this like philosophy that I had never seen before in my life. It actually came out after I graduated that was related to what I was instructing on. I had to review the hell out of it to know what the hell I was talking about because it was such a like